I'd like to welcome everyone for joining us for the conference called Serverless and APIs Conference. For the next roughly 3 hours, we're going to be presenting several different industry experts who will be discussing different aspects of building APIs and serverless technologies to help you either get started on your journey with serverless or APIs or taking your skills and bringing them to the next level. So before we begin, let's kind of talk about the actual event and schedules we have planned for this. So starting off, I'm going to give this quick opening address. When I'm done speaking, we're bringing on Rodric, who will be discussing unleashing the potential of stateful serverless computing. So if you're interested in building stateful serverless apps, definitely stick around for that. After that, we're going to bring on William, who's going to give a presentation called Low-Code Serverless GraphQL APIs in a Cloud-First World. So regardless if you have experience with GraphQL or maybe looking to take those skills and improve upon them, definitely stick for that. After that, we're bringing on Allen, whose presentation will be power tuning your serverless APIs for happy customers. So obviously, you're not just building an API for yourself. You're probably also building it because you want your customers to be able to use it. And if you're interested in building a customer-first API in mind, definitely give that a try. And lastly, we're going to be wrapping it up with a security discussion from Keith, whose presentation will be API security when failure looks like success, which I think is a really great way to wrap up this presentation, because it's one thing, basically learn how to build these APIs, and then not only that, make them better by making them more secure. So I think that's a great way to wrap up this presentation. So before we begin, I want to go ahead and discuss some of the community partners who have helped us be able to reach out to various communities about this event, to share it and bring people on board so that we can not only share our communities together. So the first community we're talking about is Incubate IND. So they are India's largest and fastest growing community of technology innovators, including startups and student innovators. They also are a great choice if you're looking to organize hackathons or join a hackathon. So if you're a programmer looking to try to improve your skills, check them out. Next, we actually have a partner called the Self-Taught Programmer. The Self-Taught Programmer is a Facebook group and is a place for programmers or aspiring programmers to share their experience, get help, ask questions, and even post tech news. So if you are a developer and you want to be, or if you just want to be a developer and you're looking for a community on Facebook, then I really do believe that this is the perfect place to start. Now, for our last community partner, and I actually see a few members in the chat right now. So hey, everyone. So this is our last partner is GraphQL Berlin. GraphQL Berlin is a regular meetup of people interested in GraphQL and its ecosystem. They have speakers from all over the globe speaking about the latest developments in the GraphQL world. We're excited to actually have this community on board because we're actually hosting a session on GraphQL, as I mentioned before, during this conference. They also have an event coming up where you can win access to an advanced React course coming up, which will be coming up in March. So if you're interested in joining a competition for this sort of thing, definitely look into this group. All right. So now to go ahead and bring on our first speaker for the evening, we're going to go ahead and bring in Rodric. All right, Rodric, how you doing?
Good. How are you, Jamie? Thanks for having me on.
Of course. So for the people that don't know who you are, could you please give a quick little introduction about your background?
Yeah, I can do that. So I am co-founder and CTO of NIMBELLA. I've been at NIMBELLA since its founding 2 years ago, so a 2-year-old journey. Before that, I was at IBM. One of the last projects I did at IBM was building what turned into IBM Cloud Functions, which is IBM's serverless offering. This was a project we built and then open sourced as part of the Apache Foundation, and that project has been picked up by other companies. It runs and powers Adobe I/O's cloud, Naver's Lambda service, NIMBELLA's cloud, among others who are running on-prem. So my experience with serverless has been really since the early days of this whole journey that we're all on. I'm really excited to sort of talk about what we're doing at NIMBELLA in this space.
Nice. Well, hey, I do appreciate you coming on board and like sharing your knowledge with all of us. So I'm going to go ahead and leave for now. And by the way, everyone, while Rodric is talking, if you have any questions, definitely ask them in the chat. I will be collecting them, and we'll be having a Q&A at the end of this presentation. All right. So Rodric, I'll leave it to you.
All right, so here we go. So what I'm going to talk about is unleashing potential, and it's really trapped potential. It's inside every one of us as developers that get bogged down by what it takes to get an application to run in the cloud. And moreover, I'm going to talk about serverless as a way of developing applications to sort of unleash that potential, more so stateful serverless. And what I mean by that is applications that we develop today have state. Any interesting application that you build will have some aspect of state. So what do I mean by that? What does it take to build stateful serverless applications? This is what this talk is about. And I'm really pleased by the lineup of speakers that we have today. I'm really just the opening act. Real rock stars are coming after me to talk about other interesting work in this space, and stay tuned for that for sure. So how should we start? I think I'd like to start by posing this thought experiment. If you're building an application, you have an idea, and you want to build this application, and you want to share it with the world. What does it take to do that? What I mean by share it with the world, it's essentially an application you want to build that becomes part of a mobile device or runs in the cloud, essentially, so that you can share it with a client in the web browser. And think about what it would take you to go from, hey, conception to actually making this thing real. And if you try to go through that, you'll realize there's a lot to actually building an application. You might think about, okay, I've prototyped enough. How do I actually make this application real? And I think about, okay, I'm going to host this on some of the big cloud providers. Why is that? Because the big cloud providers have everything that you need to take an application and put it in a cloud. Here I'm showing the AWS console, not to pick on AWS. I think they're a great cloud, and we use them ourselves. If you log into the AWS console and you sort of look at everything that they offer, it's kind of an eye chart, and that's the screen that I have there. Where do you start? And so unless you're an expert in AWS and an expert in sort of understanding how to take an application, build it in the cloud, this is where ideas go to stagnate. And you might get frustrated by this, and it slows you down. Big cloud providers have to give you all of that, because if you decompose a cloud application and you look at what it actually takes to run something in the cloud, well, you need lots of things. You need lots of components. It starts from just having a domain name. And if you're going to build your application in modern web, then it has to be HTTPS encrypted and have SSL certificates for that. If your application has a web component, a front end, then you want to deliver that content through a CDN, a content delivery network. If you're building APIs, sort of back-end function, back-end logic, then you need some way of creating those APIs, describing them, allocating the compute resources for them. And I touched on any interesting application has state, and there's many forms of state, from the web bucket that holds your static assets. This is your HTML, your JavaScript, your CSS files, to an object store if you're dealing with files. So if your application is about handling images or speech, audio files, you need a place to be able to upload those and process them. Might also need a key value store. Examples are, for example, storing session state and tracking who your users are, telemetry. And of course, you might also need a database for persisting information that's sort of long-lived about your application and how it interfaces and interacts with the rest of your users. So there's a lot of components to building a cloud application. And that's why, when you look at the big cloud providers, there's a lot there in terms of what they offer you, but there's also a lot of complexity. But because of that complexity, there's been an opportunity. And this has essentially led to a change in the cloud landscape and what's given rise to simpler experiences. If you've used DigitalOcean, if you've heard of them, it's a much simpler experience. They may not have everything that AWS offers, but they have enough for you to be able to, if you want to rent servers and deploy a database or have an object storage, it's a much easier experience for people to get started. Heroku is also very good at this, where it's a platform as a service. So it gives you a different way of thinking about how to package up your application and deploy it, including Heroku Cloud. And it takes some of the complexity away by focusing on sort of a vertical and allowing you to sort of do that more quickly. More recently, we've seen the rise of Jamstack development. These are applications that you might build that have a static component served from a CDN, a content delivery network, and backend APIs in a model called Jamstack to pattern after the LAMP stack and things that came before it. These are essentially application model as a service, where you build your applications, they're deployed and hosted for you. You start to not think about, hey, how am I running my APIs? How am I going to scale them up? And of course, there's a NIMBELLA cloud, which takes some of the ideas from Jamstack development and the developer experience that kind of model gives, and sort of makes it portable so that you can run it on not just a NIMBELLA cloud or Netlify or other clouds I have here, but on a cloud of your choice. And this is the power of serverless. It's the ability to not think about the underlying complexity that the cloud providers give you, and moreover, not to think about not just the infrastructure, but any of the components you need to get an application into the cloud. So I want to start by essentially traveling back to 6 years ago, where my serverless journey started. And this was with the introduction of a service from Amazon Web Services, which is the largest cloud provider in the world today, and a service that they called Lambda. And what is Lambda? It's serverless functions. Well, if you're new to this, if you've never heard of serverless, you've never heard of functions, let me give you a quick tour of what this really means. So serverless functions means instantly reactive code in the cloud. And what I have on the screen is a small snippet of code in Node.js that just is a function that takes no arguments and returns a JSON object with a message in it, hello world. This code snippet, this function, is instantly reactive. It lives in the cloud and it's instantly reactive. When an event comes, it runs automatically. The result from that function becomes the response to the event. And so if your event is an HTTP request and you say, I'd like this function to run whenever somebody makes an HTTP request to a specific URL, then the HTTP response is terminated with the result of the function. This might seem too good to be true. And again, if you've never had an experience with serverless and this is your first introduction to serverless functions, you should see it and believe it for yourself. So if you go to NIMBELLA.io/playground, step one is write a function. Step two, you're done. Why are you done? It's because the function is the API. So any code that you write is instantly available as an API. And that event, that API access, becomes the invocation of the function. And you don't want to go to the playground. So here's a screenshot of what you might see. You'll land on the playground, and there's actually some sample code there for you, and some buttons. So you can run it, you can play with the code, edit, etc. But once you've finished writing your code, click on this publish button. And when you click on this publish button, you will get a URL. This URL is unique to you as a visitor to the playground. You can take this URL and you can put it in your browser. You can click it, it'll open in your browser. You can test it with Postman or curl or whatever your API testing tool is. You've just turned a function into an API. This is pretty powerful. But you can do more interesting things in the playground, not just a hello world. So here I'm showing a snippet of code also available as samples to image resize. So you might take a large image and you want to generate a thumbnail for it, or generate different images of different dimensions. So here I'm showing, having run this function on a large image of a cat that gets reduced into the small output that you see here. Interesting aspect of this that I also want to touch on is the auto-scaling nature. So when I create a function and turn it into an API in this way, I don't have to worry about, how many resources do I need if I'm running one instance of a function, or 5, or 100, or even 1,000. Part of the contract between you and the cloud provider is essentially that if you're following this model where I'm willing to write pieces of code that can be activated in this way, the cloud provider will automatically allocate resources to scale up and down your computation. And so if you have an API, your application is on day 1, you don't have a lot of users yet, you consume few resources. And then you go viral and your application is really popular, you don't have to change anything about your code. The cloud handles the rest and the heavy lifting for you. Auto resource scaling. It's pretty powerful. And we're talking about significant concurrency. So almost all the cloud providers today give you essentially 1,000-way concurrency, which you can get within seconds, even milliseconds. Right? So imagine now you've created a function that you've turned into an API that you can access 1,000 times a second. And the cost is very cheap. Within some limits, of what your function consumes with resources, whether it's in time or space, memory, it could cost you 25 cents or even nothing because of free computing tiers that these cloud providers give you. You'll notice that in my code, it's just a server logic, right? It's just a function logic. I didn't do anything that had to do with a server. I didn't say, hey, function, listen on a particular route or create a server instance and listen on a particular port. It was just my function. Right? The cloud provider is providing the logic for you. And I provision no resources. Right? What you saw on the playground is the real experience of serverless development. So there's no infrastructure, no server logic. You focus on just your functions. And one of my favorite parts about this model is it's not just about Node.js. So if your favorite language is Python or Go or Swift or Java or Ruby or PHP, you can do this too. You can even package your code as a Docker container, if you're familiar with Docker containers, and you can run that in the same model. So this really means that you can package your code in just about any possible way that you can think of, and then you can make it instantly reactive in this way, instantly scalable, with no infrastructure for you to worry about or to even think about. This is serverless. And the combination of the thought that I don't have to think about my servers anymore, I don't have to think about container management or VM management, I don't have to think about auto resource scaling, that combination leads to focus, which means that I can create and run my applications faster and sooner. And there's the benefits. So reduce cost of infrastructure. So if my application has no users, my API has sort of activity that bursts in the morning and then quiesces throughout the day and then bursts again in the evening, I don't have to have servers that are constantly on powering my application. The resources scale up and down, so my costs go up and down. And as my usage increases, my costs will increase, but that's a good problem to have. So you can think of this as sort of relating to a utility model where you pay for your electricity when your lights are on, and if your lights are off, you're not paying for that electricity. And of course, the accelerated time to production. So imagine again to the original thought experiment I posed. You have an idea, and you want to get it into the cloud so that it's actually published and usable by others in the world. How do you do that? Now imagine how much faster you can build those applications by adopting serverless and not having to think about the things where you might get frustrated, that distract you from the actual value you're creating, because the cloud providers now are taking care of that burden for you. There's lots of benefits to serverless, and these benefits that I just outlined are not just my own musings. A recent survey by CodingSans, which was sponsored by a number of companies in the serverless space, found that developers associate with these benefits, the ability to not think about scaling and having that flexibility in scaling automatically managed for them was the top feature. The speed of development, right? Just think about how much less code you have to write. And less code means less responsibility, means you focus and you can test on the things that are important to you. The cloud provider can automate the rest, and that's really the promise of serverless computing. Decrease system administration. I mean, there's essentially no system administration at all, right? You still have to administer and operate your code itself, but all of the underlying infrastructure is gone. It's no longer your responsibility. You shifted that to somebody else. And this model of computing, focusing on just serverless functions, has been growing exponentially. So from 2015, where Amazon was processing 2 billion serverless functions a day, to last year, when they were doing 2 trillion a month, That was an exponential growth in this model of computing on Amazon alone. Right? Every cloud provider today offers this model of computing, and you can imagine the growth is very similar. But in the totality of the compute that's happened in the cloud, this is very small still, right? A lot of compute is still happening on servers in classic models where applications are big giant monolith, but not for new applications. And so if you're building something new and you haven't thought about serverless, this is something you consider and you should look at. And this really is the point of this talk series. Not just my talk, but the ones that are coming after me. And I think you're going to get a good sense of how powerful this model is in terms of focusing on the value and not thinking about the underlying infrastructure. And if you put this in sort of the historical context, it's been happening over time, right? So if you go back decades, or even just over a decade ago, the predominant way of building applications was to buy a machine, and you would host your application on that machine. Over time, we shifted, and the economics shifted, so that instead of paying for a machine, which was expensive, paid by the hour for infrastructure or platform as a service, things like Heroku. Now we're in a world where you can pay per request. You can even get billed down to the level of a single millisecond of compute, and that's functions as a service. Right, so serverless is much bigger. It's about this notion of focus and shedding burden to the cloud providers. Functions as a service is one model of serverless computing. And this evolution has been happening over time. And it's not just an economic incentive that's there, but it's also a gatekeeping that's been sort of slowly eroding as we push and push up the stack in terms of enabling more automation, more abstraction. Now, every developer in the world could really have this power of the cloud at their fingertips. That's much easier for them to get into and build applications and deploy into the world. And if you look at AWS case studies that have been published, there's a lot of companies, some of these logos you might recognize, that have been adopting this model of computing, some to transform their entire business. And what they're finding is that they can use this model of computing to unlock the potential within their organizations. Entire teams who are dedicated to sort of building and managing infrastructure now can focus on new value creation for the company. And that's because you need smaller teams to sort of operate the infrastructure, if at all, and all of that workforce can be retrained, essentially do new things and more powerful, beneficial things for the company. And serverless adoption is happening in essentially every industry, from financial services to healthcare to IT services and consulting. And I expect this pie to just grow in terms of the number of segments that is partitioned, because as developers get more and more in tune with this model of computing, you're never going to want to go back. It's really transformational. And the use cases, what is this good for? Well, there's a lot of things that are good, that is very good for today. Building REST APIs, but data processing and doing things that are batch processes or sort of offline asynchronous is also a use case that people are using it for. And increasingly, we're seeing it in not just building websites, but DevOps automation, GraphQL that you're going to hear about later, building chatbots, building e-commerce sites. Machine learning has been driving also a number of use cases and the erosion of constraints that this programming model has put on developers in the early days, because it's a very powerful model, like I said before. But some of these models are also pushing this, this paradigm into developers wanting more. And what they want is this concept of serverless applied to data, applied to state management, not just compute. So my favorite thing to say about serverless is that it's inevitable. So maybe today you aren't using serverless, maybe you haven't heard about it yet, but it's not only an easier and faster way to get started, but it has so many properties that are desirable and I think necessary to remove a lot of gatekeeping that's preventing people from making use of the cloud and delivering their great ideas into the cloud. The totality of it is it makes the cloud accessible. And for a number of these reasons, the serverless evolution is inevitable. And so the sooner you get on with sort of understanding what this model of computing deliver in value to you, I think the better you can start unlocking that trap potential and delivering value better, faster. And this is part of our mission at NIMBELLA. We think the serverless cloud is a beautiful cloud, and that's in fact the name of our company. And one of our goals is to make the cloud not just accessible in terms of easing the burden of getting started and removing a lot of the gatekeeping, but also making that cloud portable so that you can build in this way on any cloud, not just the cloud that has the best serverless features, but in a way that you can take your applications and run them with the same feature sets on a cloud of your choice. And this is really important for developers who are in the enterprise, who typically have requirements and security considerations, integrations with existing services that they might be using. All of those requirements start to come into play. And there's a whole separate talk about that we're doing tomorrow that Jamie will tell you about later. So at NIMBELLA, our goal isn't to just think about functions, but to think about building complete applications, but doing it with the same ease and the same agility and the same quickness that you can by developing functions and running those in the cloud. And I alluded to this earlier, building applications in this model isn't just about compute. It's about memory, it's about storage. It's because if you think about an application that just runs on your machine, a lot of, you're not just writing about the compute. There's memory, there's storage. It's just a natural way of building applications. And the burden today for dealing with a lot of that is on you, the developer. Sorry, just trying to do that. Is on you, the developer. And we don't think that should be the case. So part of our mission is to bring this notion of serverless everywhere. Sorry, hang on a second. My son, who was on break, decided it was a good time to start playing with his remote-controlled car. Sorry for that. So anatomy of a cloud application, let's get back to that. Right. We touched on a number of things. And part of what I believe is happening with serverless computing today is a lot of those you should get for free. And at NIMBELLA, you do if you build an application and deploy it to our cloud, but we're also giving you more. And part of what we're giving you is the ability to take an application and use things like a key value store, to take an application and use a webbucket or an object store. Databases are an interesting area, and we're still in the early days of serverless. So there's, of course, advancements happening from Amazon with the launch of Amazon Aurora. Last year, DB, one of my favorite in terms of what they're doing with serverless and databases, Cockroach, Neo4j, which you're going to hear about, I think, in the next talk or two talks later. All looking at this space of serverless data and databases. And I think what's missing today, except for Amazon Aurora, is this idea of automatically scaling the storage, not just the resources that it consumes in terms of compute, but storage. So I don't have to think about, hey, my database should be 1 gigabyte or 4 gigabytes. It should scale up, it should scale down, just like my compute scales up and scales down. So there's a lot of work still to be done with serverless databases, and we're in the early days of that. What I am going to focus on are the challenges related to fine-grained data sharing, and that often touches on a key value store. And what do I mean by fine-grained data sharing? That's part of the promise that serverless providers give you today is, if your function runs 1 instance or 1,000 instances, they will scale it up for you. But that means that if your application is sharing data or requires any kind of synchronization, that burden is on you. So the cloud providers take their hands off and say, your applications, your functions should be stateless, right? That gives them the freedom to essentially scale you up and scale you down. But now if you need to reintroduce any kind of sharing of data between functions or between APIs, how do you do it? And this is what requires now work, right? And so getting back to the notion of serverless and the idea of focus, I don't want to think about that as a developer. I just want it to work. And one of the ways that you can think about, shared state between functions, I have a number of them, and maybe you have more. I'd love to hear more, ideas that, or situations where you felt, I wish I had some form of state or storage to do this from APIs. You can put those in the chat. We'll be checking those later. Some of the ones where I've actually used or have thought about is, my function is running, I get an alert, I really want to know what's going on. So I want to turn on debugging in production for my application. So I flip a variable and now all my functions start logging more, for example. You want to change the configuration parameter. Maybe you're doing some A/B testing and you want to tune sort of the ratio between two APIs. Maybe I could do that with quick configuration parameter change, and maybe even changing the sampling rates within my function. Session state. So if you're building an application, whether it's mobile or on the browser, right, you have to be able to track the user. Who is this session for? authentication flows, payment processing, progress meters, and counters, all are common use cases where, yeah, you can maybe use a database for that. If you're on AWS, you might use DynamoDB for some of these things. But really, a key value store is sort of optimized for quick access is much better for that. And that's part of what at NIMBELLA we provide for you. And that's this notion that your compute and your key value store are both there for you. You don't think about having to provision, storing, backing them up and storing those backups, dealing with persistence, et cetera. It's just there. You just build your applications. I'm going to show you some examples. And that storage is essentially shared between all your functions in a way that, because of the co-location, allows you to have sub-millisecond latency. So how am I going to sort of illustrate this? I want to sort of tell you a little bit more about this. So imagine your application is a page visit counter, right? Simple application, web UI that displays the visitor count that you are when you visit it. And more people visit the page, the counter goes up and up. This code is on GitHub. You can see it at github.com/nimbella/demo projects. And what is in this application? So if you look on GitHub, you'll see a organization of the file structure, if you will. That's essentially everything that's here shown in orange. There's nothing else. Well, maybe there's a README file. So I have some assets that are for the web, some assets that are for my APIs, which are managing the counter, and metadata about the page. But everything else, in terms of how these resources get mapped to the cloud, is provided for you by the NIMBELLA tooling and by the NIMBELLA cloud, whether it's the compute, the data storage, the object storage, all done for you. And this is the way it should be. How do I deploy this application? So I can use a NIMBELLA Workbench, which is directly from my browser. You don't even have to download a tool if you're just trying to kick the tires and see, is this model really true? Right? I can do nim project deploy. Nim is short for NIMBELLA CLI. And I can give it to GitHub URL for my repo, and it will produce some output like what you see on the screen. And live is my application. That's it. One step, write your code. Well, two steps, write your code. Second is deploy it. And you can do this too, right? I think seeing it is one thing, doing it for yourself is other. So if you were tempted to try this and see for yourself, you can create an account on nimbella.com. You can follow the links for the NIMBELLA Workbench, and you can type the command project deploy or nim project deploy with the GitHub URL. So if you're doing this just now, live as I'm speaking, you might see a 2 to 3 second delay after allocating some resources for you. This is for one-time delay, but you'll deploy your application, and within a few minutes, it's live. So what happens when you do nim project deploy? So your static assets, so this is my index page and my logo, which are in a web folder, automatically get deployed to a domain name that's unique to you. And you'll notice it's HTTPS, it has an SSL certificate, nothing you have to think about. My page visits has 2 APIs, one for the counter. Every time I have a visitor, I want to increase the counter, or I want to retrieve the counter. And then some information about when I deployed this page so I can see when I started counting. So those functions become the APIs. Here I'm doing it in PHP just to illustrate that I can pick whatever language I choose to implement these APIs. So it's, you can pick whatever language you prefer. And in terms of digging in and sort of looking at what is in the counter, this is the entirety of the code. I required an NIMBELLA SDK, which is an open source implementation. So you can go actually look at what is in that NPM package. Here I'm showing it a node. And it says, NIMBELLA, give me my key value store. And we leak a little bit of the abstraction here in that you can see that the key value store is implemented using Redis client. I call a function on the Redis client that says increment this counter, and I return the result. That's it. Here's the same code. Whoops. Shown in Python and in PHP, which is what the code you'll actually see in GitHub. Same code. This is the totality of what's in that function. There's nothing else, right? So the ability to sort of say this is a simple counter. All I need is the key value store, bump up the counter, and return the result. Right? And you can do this in multiple languages, like I said. The other notion of state and challenges I wanted to touch on is when you're running in this model where your functions are automatically scaled by your cloud provider, you're giving up control over what resources are allocated, where your code is actually running. This can lead to a problem if you're fetching data every time your function runs from an external store. And not every time you do that, there's a cost. There's not only just the performance costs, right? The time it takes to transfer bits back and forth on the wires, but also dollar costs, right? So if you're transferring a file, a large file, every time your function runs back and forth, there's a dollar cost attributed to that. And this might play out in a scenario where you're doing something with AI and ML, artificial intelligence, and machine learning. So we have a demo application also on GitHub that you can deploy. This application is also available on NIMBELLA.io for you to try out. And it's called optical character recognition, or OCR. So with OCR, you can drag an image onto the web page, and it will upload it to an object store, right? So we have an image, it goes into the object store. That event essentially generates some image to text translation to happen. So the image is, there's a model that's applied, machine learning model that's applied that says, please recognize all the characters in this image and then translate it to text for me. And so what you're seeing as a screenshot is this application in various stages. You'll notice in one, it says waiting, 0% completed. In the other, you actually see the result. In the third, you can do text-to-speech, right? Some different APIs you can call. And I just wanted to focus on one part of this, which is what happens in the image-to-text translation. Right? So there's an image that got uploaded. Where do you upload it, right? So now if you have to think about the object storage, and you're building this application on a cloud provider, you have to go and provision those resources, make sure you got the security settings right. Part of NIMBELLA's mission is don't think about that. We give you, just like we give you a key value store with that simplicity, you have one available to you for object storage as well. And so if you say, give me an object storage link, you upload the image to it, and now that kicks off the processing for the OCR. But that processing requires fetching a language model, right? This is a pre-trained neural network model that you've built offline and now you want to use. If you're running one instance of the function, right, it might fetch the model and then locally cache it. That's great. But if you're running 10 instances, 100 instances, 1,000 instances, it would just be wasteful, right? If every one of those functions had to pull that machine learning model from the object storage so that you can actually do the processing, right? It should just be obvious. This is wasteful. We shouldn't be doing that. And so you might think about, well, how do I optimize this? And it turns out that on some of the clouds, you can't. You can't do it at user level. Or you might have to write lots of new code to sort of deal with that. Again, it's breaking the promise of serverless, where I don't want to think about that. It should just work. And part of what happens when you're using serverless computing models with functions today is you lose this notion of data locality. And so at NIMBELLA, we're restoring data locality that accommodates not just data gravity, in terms of where my data happens to be. I want to do the compute close to that. And give you essentially serverless compute, but in low-level optimizations that says, hey, I noticed that you have this object store file that your functions need. I'm going to take care of optimizing the data flow for you. Right? So now that's work you don't have to do. Your function just says, open the file and read it. Right? In the same way that when I need a key value store and a counter, it says, give me my key value store and create a counter for me. So it's freeing you from having to write code and not have to worry about that. Now, we've done this in a way that uses object storage on two clouds, on Google Cloud and on AWS. You can pick and choose in some cases if you're sort of, depending on the tier of computing that you're using, or you can just be on one cloud and all of your data is just there. And part of the automatic management is to save you time in terms of development cost, save you time in terms of compute cost, net bandwidth utilization, and save you money, right? Because at the end of the day, if you're shipping data back and forth between your resources, nothing's free, right? In the cloud, everything gets shared. And so part of shifting that burden to the cloud is to allow the cloud providers to optimize these things in ways that they can do it by de-platform integration. So our goal and sort of my message is, by looking at serverless computing, considering what it can do for you, and understanding its benefits, you'll be able to create, deploy, and run your applications faster And you'll be able to do it anywhere with technology like what we're developing at NIMBELLA. The fundamental theme here is that the infrastructure and everything related to the cloud anatomy of building an application becomes someone else's headache. And that's the best problem to have, is I don't have to worry about it. It's not my headache. It's the cloud provider's headache. And that's okay, because the cloud providers have the skills, the expertise to essentially do that at a scale that is very hard for everybody else to do. So it's the right kind of division of labor between my value creation and the infrastructure burden that really should be the responsibility of the cloud provider. So in the last few minutes, I want to talk to you about, serverless, having some fun, and even winning some cash as being part of the competition. So we're running this campaign called FaaS Wars. And again, if you're new to serverless, maybe if you've dabbled with serverless and you want to have some fun, I want you to check this out. Kind of like the playground, this is very, very easy to get started. And this is a bot competition where you can program a bot to essentially battle another. And I took this picture a few days ago, 95 fighters, 230 battles. As of last night, when I updated this picture, we have 176 fighters worldwide, and over 1,500 battles have been fought. So it's fun. And one of the most surprising things when we ran the first round was that the winner didn't have a very complex winning strategy. And there's cash prizes here. So I encourage you to try it. You might have, I'm sure you'll have some fun, and you'll even win some cash when we run the next competition. So, if you want to try, go to nimbella.io/playground and have your kicks with sort of serverless functions, and you can go on from there to build applications in the cloud. If you want to play, go to faaswars.nimbella.com. And if you've enjoyed any of this, you have questions that I can't get to in this talk, or you want to engage with our community, you can join us in Slack on nimbella-community.slack.com. So before I end my talk, I want to sort of thank the speakers who are coming after me. Like I said before, I am just the opening act. Some real rock stars are going to follow me, and I'm really looking forward to what they're going to tell you and share with our community, both from GraphQL and thinking about sort of what does that mean in terms of data and API management, to engineering your applications for performance in this model. They're going to take some of the air out of the bag. So I was sort of saying serverless is the greatest thing, but now you're going to actually see from real practitioners, there are some things that you have to do. There is a cost for some of this. And of course, API security. And what does that mean in this new world of serverless computing? So 3 great talks to follow me. And I encourage everyone to join in and listen to that. So with that, Jamie, I am done.
Nice. Well, hey, Rodric, thank you so much for getting us started, and also just giving a really great presentation in general. I've seen several speeches from you. Yeah, they're always good.
Thank you.
So we actually have about a little over 5 minutes left for like a Q&A session. So you actually wrapped it up at a pretty good time. So one of the questions I have for you is that, one of the things that, we've discussed in the past is sort of how you were sort of there kind of in the early days of serverless and kind of seeing a lot of the really early benefits of what serverless is capable of and the kind of value it can provide for users. In your opinion, early on when you were first looking into serverless as it was growing in the early days, what were some of the benefits that really stuck out to you the most? And do you feel that those benefits have increased in power as time gone on, or are they staying the same and that's still good?
Yeah, I think the benefits have increased over time. And that's because, this model, which started really with just Lambda, serverless functions, has now really brought in to sort of apply these principles to other areas. Can we do it for memory? Can we do it for other aspects that are required when you're building an application in the cloud? So whether you're deploying an application on NIMBELLA or AWS using Amplify or Vercel or Netlify, right? I don't have to think about my domain name. I don't have to think about the SSL certificate. I don't have to think about my CDN. Right? It's not just functions. So it's growing to encompass everything. And it's like I said, if you start developing in this model, you don't want to go back. And so I view this model as just growing to become inevitable. Everybody will want to develop in this way. You give up some freedom by doing that, but it's a fundamental shift in how you build and deploy applications that I think is just empowering in the end, in the totality of it. What I do see happening is also some of the limits that were there and some of the constraints that were there in the early days are going to slowly erode over time. And we've seen some of that. So what do I mean by that? Let me give an example. So when Lambda first came out, I believe the maximum duration of a function was 5 minutes. Today, I believe it's 15 minutes, right? So what did that mean? Well, I had to write my application the way finish in 5 minutes. And if it didn't, death was certain, just like in real life. Your resources got killed and everything that was allocated to your application was destroyed. That's a hard model when you're trying to do batch processing or some asynchronous task. I have to make sure I finish in 5 minutes. And if not, I have to save everything, checkpoint it, restart it. Right? People started doing that. A great project out of Berkeley called Pyren, applied this model to HPC, high performance computing. And over time, we've seen Google say, well, you can run for 9 minutes, and now AWS says 15 minutes. And in the end, there's going to be no limits. That's, I think, because if there's no real penalty, developers will just game the system, say, I don't want to think about this. I'm just going to set the maximum limit and not really worry about making sure I finish within 5 minutes or 5 minutes and 1 second. They're always going to want more. And so I believe that over time, we will see more and more erosion of some of these limits that are happening. So the benefits themselves will just continue to grow over time.
Nice. Okay, so another kind of a quick question. Someone a sort of a new-ish developer asked an interesting question. He said, I find the idea of building stateful apps really interesting, but I'm still fairly new developer. I was curious if you had some examples of different type of serverless APIs I should build. That would be really simple. What are kind of serverless APIs that I should be building starting out with?
Yeah, so we've built a number of starter applications that go from really simple to more complex, and we've put them out on GitHub so that you can go look at it at your own pace, dig through the code, understand what it actually does, and of course join us in Slack to ask questions. We have a very helpful community and a helpful team to help you get on your way. So we've tried to create applications very simple as my page visits counter, right? You saw it's a few lines of code, but that model of I just need a counter, right? Whether you're doing it for a visits counter or some telemetry for your application, you want to know how many times somebody uses something, right? It's a nice way of sort of storing that information and being able to get at it later. If you're building applications that require authentication flows or payment processing, if you're working with Stripe APIs, et cetera, sometimes you need a little bit of extra storage, and key value store is a useful way for that, a useful way of doing that. Object storage, we also have some examples. So the OCR example is one. We have some others there. So I think my first pointer is go there, and if there's something that's not clear, let us know, and we take that as feedback, and then we can build something for you. Or if you have an idea, you think it's a great starter app, open a pull request, and we'll get it into our repository of applications. It's all open source, Apache licensed. And it's a great way of both contributing and helping to grow the community. Nice.
Okay, so we have time for one more question. We actually got a one in the chat. I'm going to use a feature see if it actually shows. Okay, cool. Daniel K asked, what about the issue of cold starts?
Right, cold starts. So what is a cold start first? So a cold start is the first time your API runs, right? So you have an API event, the function has to run. Where do you run it? So the cloud provider has to allocate resources for that. And that's called a cold start, as opposed to a warm start, which is, say, the second activation close in time. So I've allocated resources, they're still there. And so you save essentially overhead of the cloud provider having to allocate resources for that. That's one of the limits and sort of complaints early on is, oh, cold starts are really a problem. Can I really use this for low latency operations? And over time, people have developed techniques for dealing with that, from pinging the API, sort of just sending in an event that says, don't do anything. I just need my resources to be live. But if you think about it, that's sort of silly, right? Now I'm having to write code to do this stuff that I shouldn't have to do. And over time, we've seen AWS introduce things like provision concurrency, where you don't have to pre-warm it. They'll just have some resources that you're willing to pay for that are just there and ready. We take different approaches to doing that and sort of optimizing. And I think this is an area over time, again, we'll see the cloud providers get smarter at it. It's a very powerful way of sort of looking at all the traffic that's coming in and the cloud provider doing speculation and predictions for you and being able to sort of predict when your APIs are going to run based on historical data. So we're actually doing some collaborative work with that at people at MIT. And so there's lots of interesting opportunities there. Today, the reality is sometimes you will have cold starts. And for the majority of use cases, it's really not that bad to be an impediment for you to get started. And if there are ways of sort of mitigating that, whether it's through coding techniques or by paying more for having resources pre-provisioned for you.
All right, so that was a great way to kind of wrap up your presentation. Thank you so much for answering those questions at the end. I'm going to go ahead and move on to William now. Rodric, do you have anything you'd like to say before we go ahead and wrap up?
No, thanks, Jamie. Thanks for the questions, and let's get on with the next talk. I'm looking forward to William's talk.
All right, have a great day, Rodric. All right, so now I'm going to go ahead and bring on Rodric to the stream, or sorry, William to the stream. We'll bring on Rodric again. Yeah, so, all right, so hey, William, how you doing?
Hey, Jamie, I'm good. How are you doing?
Doing great. So, for people who do not know about you and your background, can you please give us like a quick little introduction as to who you are?
Sure. Yeah. So I work for a company called Neo4j. Neo4j is an open source graph database. I work on the developer relations team, and my function is as a software developer, but instead of working on the core database, I work on tooling around the database. So extensions, integrations, trying to make Neo4j easier to use and integrate with different frameworks.
Nice. And how long have you been doing that?
Oh, good question. Let's see. I think I've been at Neo4j for a little over 5 years now. Before that, I worked for a number of startups as an engineer.
Oh, nice, nice. Yeah, so just want to go ahead, before I bring you on board, just want to say thank you for coming through and actually giving this presentation. I'm going to go ahead and share your screen real quick. All right, so, all right, got the screen shared. I will go ahead and let you get started.
Great. So hi, everyone. Thanks for joining today. Like I said earlier, my name's Will. My talk is titled Low-Code Serverless GraphQL APIs in a Cloud-First World. And what I'd like to do is talk about how some of these concepts can be used together in the context of building full-stack applications, building and deploying full-stack applications, really. So we'll talk about what is GraphQL, how do we build GraphQL APIs using Neo4j and using other data layers. We'll talk about how we can take advantage of some low-code tooling specific to the GraphQL ecosystem. And then we'll talk about what it means to deploy applications like this in the context of taking advantage of serverless and other cloud services. So the slides are linked here, this bit.ly link, and I think Jamie can share that in the chat as well. So like I said, I work on the developer relations team at Neo4j. That's my Twitter handle and my personal site, which has a blog and a newsletter that I publish every couple of weeks. So if that sounds interesting, I would encourage you to check those out. I also have been writing a book called Full Stack GraphQL Applications with GrandStack. GrandStack is GraphQL, React, Apollo, and Neo4j database. And so what this book does is tries to capture some of the things that I've learned building applications with these technologies, and especially working with users in the community to try to talk about, okay, what are best practices for building full stack applications using these technologies? How do they work together? And then, of course, how can I take advantage of things like serverless low-code tooling that can really be value adds for developers? So this book, I'm about 70% done at this point. There's 7 chapters now. It's available in early release. This link here, grandstack.io/ebook. This is a free download of the chapters focused on building the backend. So if this sounds interesting, just go to that link and you can download 3 chapters focused on the backend to give you an idea of how these technologies work together. Cool. So what I want to do in this talk is, again, talk about how these technologies can be used together, how we can take advantage of modern cloud services to build and deploy these applications. So let's just jump right into that and start talking about Neo4j first as our data layer. So Neo4j is a graph database. So fundamentally, Neo4j is a database management system. The way that Neo4j is different from other databases are a few things to point out in that area. One is the data model. So when we're talking about a graph database, we're talking about specifically the data model that the database uses to allow you to model, store, and query your data. So in graph databases like Neo4j, that data model is called the property graph data model. So we have nodes, these are the entities, and we have relationships that connect the entities. So unlike other databases, relationships in a graph database are first-class citizens and explicitly part of the data model. This means that graph databases optimize for traversing and working with this graph. So the other big distinction of graph databases and other databases like relational databases, document databases, are that the database is optimized for traversing the graph. So going from one node, following relationships to others, and so on is very, very, very efficient. That's the thing that graph databases are optimized to do. So you can end up doing very complex traversals through the graph with very, very large data sets. We use a query language called Cypher to work with the graph. You can see an example of Cypher up here, where we're sort of drawing this almost ASCII art-like notation to describe a graph pattern. This query comes from the Panama Papers dataset, which was an investigative journalism project that looked at offshore legal entities and the people connected to them. The journalists used Neo4j to make sense of this data because it was a very complex network where we had maybe an officer of a company. That company owns another company that may be a shareholder in another company that may be on the board of another company that owns another company that owns an asset. So there's this very long chain to connect the actual person through these legal entities to actually connect them to this asset. And a graph database is a great way to represent that. Anyway, there are lots of interesting things you can do with a graph database. Graph analytics is one of these things where we use graph algorithms, things like PageRank, community detection, to add sort of enhanced features to our application. Data visualization is an important aspect as well, as we're trying to understand the data we're working with. Neo4j has a cloud service called Neo4j Aura, which is a database as a service offering, which we'll talk about a little bit in a minute. And then there are also integrations for building tooling around the database. So we'll talk about the GraphQL integration for Neo4j, which helps us to build GraphQL APIs with Neo4j. So really, you can think of Neo4j as a platform core around the database. We have tooling that is maybe interesting for the more analyst personas, where they're interested in running graph algorithms and graph data science, and graph visualization is important to help them understand what's going on there. On the other side, we have more transactional use cases with developers building applications that are working with graph-shaped data, and where that performance optimization for traversing the graph comes into play. So we're going to be talking more about the left side of this chart, where we're talking about developers that are interested in building and deploying transactional applications, and specifically in the context of GraphQL. Let's take a look just quickly to give you a better idea of what some of the Neo4j tooling looks like. So this is Neo4j browser, which I have running locally, I have Neo4j desktop with a data set loaded. If I run DB schema visualization, you can see this data set that I have loaded. This is just a sample data set of users that have written reviews that describe a business, and the business is in a category. So for example, let's look at some Cypher snippets here. So this first query I'm going to run is looking for a node with the label user. So labels are how we sort of describe or group our nodes. You can think of a label as kind of like the equivalent of a table in the relational world. And then we can store arbitrary key value properties on these nodes. So we then describe a pattern. In this case, we're indicating a node pattern, which is wrapped in parentheses. So you can see how this is sort of an ASCII art representation of a node. So we're saying find a user node with the label will. Here's the will node. And if I double click on this, I can start to traverse out through this graph, and I can see the reviews that this user wrote and what businesses those reviews were connected to, and the categories and the other businesses in these categories. So I can start to traverse out the graph that way. But I can also describe more complex graph patterns in the query. So here, I've now described a traversal from the will node now to follow these outgoing wrote relationships to find the reviews that this user wrote, and then what businesses are those connected to. So we're drawing this sort of ASCII art representation, sort of like an arrow here to connect the user to the review node. You can think of this as kind of the equivalent of a join in SQL and in the relational world, but sort of a more declarative and pattern-based approach of expressing that. So I get back the traversal of this graph pattern that I specify. So now I can see, okay, here's all of the businesses this user has reviewed and the reviews for each of them. Now, one thing I might want to do in my application is give personalized recommendations based on a user's preferences based on their previous reviews. And these kind of recommendations can be expressed in Cypher as a graph traversal. So here, we're expanding our pattern a bit to find the businesses that this user reviewed, what category are they in, and then looking for other businesses in those categories that this user has not already reviewed. So what are businesses in the categories that you like, that you haven't already been to? Those might be good recommendations for you. And so here's 3 businesses that this user might be interested in. So that's a quick look at Neo4j, Cypher, Neo4j browser, some of the developer tooling we use to work with Neo4j. Let's talk about how this fits into the context of a larger application. So rather than using just the Neo4j browser developer tooling, how do I actually build applications using Neo4j and GraphQL? Well, let's look at a podcast application that I've been building. I called this grandcast.fm because it uses the grand stack. So we're using GraphQL, React, Apollo. If you're not familiar with Apollo, Apollo has tooling for using GraphQL on the server side. So we'll use a tool called Apollo Server for building GraphQL APIs on the server, and then also the React integration for Apollo Client on the front end to work with GraphQL in the front end of our application. And then React is a JavaScript UI library. So let's look at this podcast application. So there's essentially 3 views in this podcast application. Search. So as a user, I want to be able to search for podcasts. So I want to type in a keyword or the title of a podcast, see a list of podcasts that match my search, and be able to subscribe to them. we have a feed view. So once I've subscribed to podcasts, I want to be able to see all of the episodes of the podcast that I subscribe to. And these should be by default, maybe ordered in most recent first, but also maybe I want to bring in some personalization. I want to bring in some of those sort of recommendations, like what we saw in that business application. So some personalization in the feed also would be helpful. And then for a specific episode, I want to be able to look at the details. I want to see the show notes. I want to be able to play it. I want to be able to add it to a playlist, this sort of thing. So on the front end, I have maybe React components that I'm using to describe each one of these views. And those React components encapsulate the data fetching logic, in this case through GraphQL, to be able to fetch the data needed to render that view in our application and sort of hydrate that component. So here are 3 GraphQL queries. If you're not familiar with GraphQL, GraphQL is an API query language, and it allows the client to specify the fields and sort of a traversal through the data graph of exactly what data to traverse and bring back to the client application. So for the search view, I have a podcast search entry point. In GraphQL terms, this podcast search, this is called a query field. And it takes an argument, the search terms. This is whatever the user is typing into that search box. And then down here, these fields, so things like the iTunes ID, the title, description, these are part of what's called the selection set, where I'm specifying what fields to bring back. And my React components are going to encapsulate this data fetching logic because that component knows these are the fields, and only these fields are needed to render this view in my application. If we look at the feed query, here we have a bit of a more nested structure, because for each episode, we want to also traverse to the podcast. So in our data model, a podcast node is connected to an episode node, and I want to traverse that. I want to express that traversal in GraphQL, and then bring back just the title field from the podcast. And similar idea for the episode detail. So that's what the GraphQL queries look like. The data comes back as essentially JSON objects. And the nice thing here is that the shape of the response matches the request. So if we look at the fields that are specified in the GraphQL request, that's exactly what we get back in the JSON response. We also have some type safety here, which we'll talk about in a minute. There's an idea of a GraphQL schema and type definitions. So if we're using a type-safe language, something like TypeScript, we have that type safety guarantee from the API, which is quite nice. Now, at the data layer, where does this data come from? Well, for our search view, we're actually wrapping another API, and in this case, it's a REST API of a service called the podcast index. So one thing to point out here that I think is really valuable is that APIs are composable. And especially GraphQL, I think, lends itself nicely to being able to compose fetching data from other resources. Some of those resources may be other APIs. So in this case, we've wrapped the podcast index API to sort of outsource all of the logic for maintaining a podcast index and how to have efficient search against that. So we're treating that sort of as a service. Now for the feed view, that essentially gets translated to a Cypher query that then queries our Neo4j database. So we're saying, okay, for the currently authenticated user, let's traverse out to all of the podcasts that user subscribes to and all of the episodes for that podcast. And then maybe we want to just order them by most recent first. Maybe we want to use some graph algorithms to show more relevant items first, this sort of thing. But we can build that logic into the API layer. And then a similar traversal for an episode where we're essentially looking up an episode by episode ID and then traversing to the podcast to get the details we need. So let's look at how we would deploy that application. And in this case, maybe looking at it from the user's perspective. So a user in their client, either in a computer or a phone, whatever, their web browser, goes to grandcast.fm. And in this case, the static assets, so things like the HTML, the images, JavaScript for our React application, that gets served by a content delivery network. In this case, we're deploying to Netlify, but it could be a similar service where the CDN has different edge locations, so it's going to be really fast that we load from an edge close to wherever this user is located. Now, their web browser then acts as a client to the API. And in this case, we've deployed the GraphQL API as a serverless function on AWS Lambda. So when Rodric earlier was saying that the API is a function, that's exactly what we've done here. The API is a serverless function that is making queries to our Neo4j Aura database cluster. So Neo4j Aura, this is a managed GraphQL service that allows us to deploy and scale up and scale down database clusters. So this is a great combination where our Lambda function allows us to scale the API requests. Those Lambda function requests are essentially stateless, so that's easy for Lambda to scale. Our database cluster has multiple instances that can handle scaling out there as well. Now, a user doesn't really care about the details of this, right? They just care that the site is fast and that it sort of looks nice and does what they expect. So what I think is more interesting area to look at is from the developer's perspective. And here, I've sort of crossed out a serverless deployment and put in service full. I think that serverless is a great term for describing the idea that the abstraction that a developer is interested in is no longer the server, right? And instead, the abstraction that a developer is thinking about is their application code. And we're not interested in maintaining a database cluster. We're not interested in maintaining a CDN, in maintaining an API server. What we're interested in as developers are the features of our application. And so really, I like to use these two terms interchangeably, serverless and serviceful, because I think really talking about serviceful, where you're embracing taking advantage of cloud services to abstract away a lot of the things that as a developer are not really key to your application that you don't really care about. So that's sort of my take. I think that those two terms are kind of interchangeable in my mind. Now, from the developer's perspective, to trigger a deployment of this Grandcast podcast application, they push their code to GitHub, and then that's going to trigger a build and a deployment using, in this case, Netlify platform, which is then going to build the static assets for the React application, push those to the Netlify CDN, and push our GraphQL API, our Lambda function out to AWS. NIMBELLA, I think, has a Netlify plugin as well, so you can use the same sort of architecture, taking advantage of all the things you get with Netlify, like the automatic builds, preview deploys, those sorts of things with NIMBELLA. Now, on the database side, we have our managed database as a service, Neo4j Aura, that allows us to scale up and scale down. And then we have all of the same developer tooling, things like Neo4j Browser, some command line tooling for configuring and working with Neo4j as well. So this, I think, is a pretty compelling architecture from the developer's perspective. They sort of just need to worry about their code, pushing that to GitHub. They don't need to worry about sort of how is that actually being built and deployed. They can sort of focus on the things that they care about in their application. So let's step back a little bit and talk about GraphQL kind of briefly here. So we saw some examples, but I think it's important to understand, really what is GraphQL and how do we build GraphQL APIs. So GraphQL is fundamentally an API query language and then a runtime for building APIs. So with GraphQL, we describe our data, we describe the schema, the type definitions, how our data is connected. That's the idea of the graph. So we're describing all of the entities, but then also how these entities are connected. And then at query time, the client can describe how they want to traverse through that graph to pull back only the data that the client is interested in. So the value here, when we saw our podcast application, we were looking at those React components. We saw how those React components encapsulate the data fetching logic there. Here's an example API. I'm going to skip over this, but this is a movies data set that you can load and play around with. If you go to movies.grandstack.io, you'll see GraphQL Playground, which is like a query workbench for working with GraphQL. Because GraphQL is typed and we have this schema, the client tooling for GraphQL can do what's called introspection, where it knows exactly what are the entry points for the API, exactly what data is available, so that we can essentially generate documentation for the API. So if you're interested in sort of writing GraphQL queries and seeing what some of that tooling looks like, this is a good endpoint that is out there in public to play around with. This is built on top of a Neo4j database. So it's important, again, I guess, to point out that GraphQL is an API query language, not a database query language. So we don't have the ability to do things like projections, aggregations, things like that you might expect in a database language. And the other thing to point out is that GraphQL exposes your application data as a graph, but it's really data layer agnostic. So we can build GraphQL APIs on top of really any data layer, not just graph databases, other databases. As we saw, we can also wrap other APIs. We can wrap REST APIs like the podcast index API in our podcast app. So the advantages for GraphQL, we've kind of hinted at some of these. So we solve this overfetching problem that we often have with REST APIs, where with REST, which is based on resources, when I'm requesting a resource, I get back all of the fields of that resource, whether my application actually needs those fields or not, which means more data over the wire, but some of those fields can also be kind of expensive to compute in the backend. So if I don't need to compute, say, like the average review, something like that, that might be an aggregation or something like that. If I don't need it in my application, we don't have to compute it on the back end. And then it also addresses this idea of underfetching, where instead of making multiple requests, so maybe I need to load the podcast and then make a separate request for every episode within this podcast to get back the data I need to render. Instead, with GraphQL, I can make a single request to return that data in my application, which has performance implications. That's going to make sure that my application renders faster. And then I think the graph aspect of GraphQL is also really important. This idea of like relationships versus resources when we're thinking about comparing GraphQL to REST, that often when I'm interacting with an application and an API, it's often in the context of relationships, right? So as the currently authenticated user, I'm interested in the connections to my podcast that I subscribe to and the relationships from those podcasts to the episodes and so on. And then we've already talked about this benefit of component-based data interactions, where I can compartmentalize and encapsulate the logic for data fetching with GraphQL in my, in this case, React applications. There's some challenges, of course, with GraphQL. I think a lot of this comes from a lot of the well understood and honed practices from REST, sort of not really translating to a GraphQL world. There's best practices and tooling that addresses a lot of these, though, but just some things to be aware of. So I'm going to go kind of quickly into how we build GraphQL services. So we start first with defining our type definitions. These become the schema that describe what data we have, how that data is connected. And then we need to build what are called resolver functions. And resolver functions in GraphQL are functions that describe how to fetch the data from the data layer. So here's an example of a resolver where we are then needing to go out to, in this case, the database to resolve the data that's being requested. And we typically have a resolver for each field, for each type in our GraphQL API. Here's a couple of examples where we do things maybe like grabbing database connections. We may filter some of the results, shape them to get them into the response that the API expects. On the right, we're using sort of an ORM to make multiple requests to, in this case, to a database. So this means our GraphQL server now may have to make multiple round trips to the database. And then we mentioned Apollo Server earlier, which is a great tool for basically taking type definitions, resolvers, mashing those together to create an executable GraphQL schema that we can then serve and handle network requests. So there's a few problems with this sort of, I guess, traditional approach of building GraphQL APIs where, okay, we have schema duplication. We're maintaining a schema now for the database and for the API. It means we have this sort of mapping and translation layer where we're going from a graph representation on the client to sort of how we're thinking of it on the back end. We end up with a lot of boilerplate data fetching code. And then this N+1 query problem, which is an example here, where we're sort of making multiple requests with this example on the right to first at the top level, basically load all the sessions from a search. Then we make another request to sort of load additional fields, do joins or traversals for the nested part of our query. So to deal with some of these problems, there is a Neo4j GraphQL integration that sort of takes a lot of these observations of folks who are building GraphQL APIs and tries to address them. So things like reducing boilerplates, making sure that you don't actually have to write resolvers for every field, using the GraphQL schema to essentially drive the database. So that's this idea of GraphQL first development, where the GraphQL types and the schema sort of drives the database data model and drives the application, and then auto-generating a GraphQL API with all of the create, read, update, delete operations based on that schema. And then the key part is at query time, taking arbitrary GraphQL requests and translating that to Cypher so that we can resolve that data from the database. Now that's good for sort of the CRUD operations. What about custom logic? Typically, we would implement a resolver function or maybe call out to some data layer from a resolver function that has some of this business logic. With the Neo4j GraphQL integration, we can attach Cypher queries to our GraphQL schema to define custom logic. So here's an example where we have a personalized recommendation query that we've attached to a recommended field in our GraphQL schema. So when that field is requested, we'll run this custom logic Cypher query to be able to resolve those results. And then the important implication of that is we're generating a single database query, so a single round trip from the GraphQL server or our serverless function to the database, which addresses that N+1 query problem. There's an example here. You can load this in Code Sandbox and sort of we'll run live and connect to a Neo4j database. The code is on GitHub as well. So I will leave that for you to explore, because I want to talk about one more concept here, and that's the idea of low-code GraphQL. So we've talked about cloud, we've talked about serverless. We haven't really talked about low-code yet, or have we? So I think that low-code is another one of these buzzwords that is going around that you hear a lot, and I think developers are not really interested in buzzwords. They're interested in solving problems. So I think really that there's this spectrum of low-code tooling that goes sort of from libraries and integrations, so things like the Neo4j GraphQL integration that provide these features for allowing us to build GraphQL APIs, but it's sort of code that we're embedding in our application, to command line tools. And there's some command line tools that I'll talk about in a second for working with Neo4j and GraphQL and GrandStack. And then all the way at the other end of the spectrum are the sort of UI-driven tools. And in this space, there is a tool called GraphQL Architect. GraphQL Architect works with Neo4j Desktop. So you can think of it as kind of a plugin or extension for Neo4j Desktop that allows you to build, test, and deploy GraphQL APIs within Neo4j Desktop. So when we start it, the first thing it will do is connect to Neo4j and infer our GraphQL schema from the database. And then we can start a GraphQL API locally and sort of go back and forth, editing our type definitions here, adding some of that Cypher schema logic. And then when we're ready, we can export and deploy our project. So that's what I think low code is, really this spectrum all the way from libraries and packages to UI-driven tools, which I think is a useful abstraction for how developers can think about and take advantage of low-code tools. So I'll leave you with just a few resources. If you're interested in learning more about GrandStack and the Neo4j GraphQL integration, all the documentation and examples are linked on grandstack.io. I mentioned the full stack GraphQL book that I'm writing that is out now in early release, and there's a free 3-chapter excerpt download at that link, grandstack.io/ebook. And then I also have been doing some Neo4j live streams focused on using GraphQL and GrandStack. That's actually where the podcast application is being built. Previously, we built a real estate search application and a travel guide. So that's kind of a fun outlet. So I'd encourage you to join the Neo4j Twitch channel or YouTube as well. Cool. So I will leave it there, and hopefully we have time for a couple questions.
All right, William, thank you so much for giving that presentation.
Of course.
Yeah, so you actually got there was a question in the chat that kind of popped up. Someone asked, hey, is the code going to be available is the code for the demo available online?
Yeah, so all of the resources are linked in the slides. You can see there's a lot of slides that I skipped. So I definitely encourage you to grab the slides. We'll make sure to post that link in the chat. Yeah, there's a couple of interesting demo pieces here. I think this one, which is sort of a business reviews GraphQL API, that again, you can just one-click Code Sandbox to spin that up in Code Sandbox, which if you haven't used Code Sandbox, it's super cool. So this pulls in code from GitHub, and it's connected to a demo Neo4j Aura instance. So I basically have this GraphQL API running, and I can see the Cypher queries being generated. But anyway, that's a good one to check out if you want to see what this code looks like to take advantage of some of this tooling and how we can basically go from a GraphQL schema to GraphQL API. And then the podcast application that I talked about, that is also online just at grandcast.fm. Currently, will take you to the GitHub repo for that.
Okay. I appreciate you answering that question. We, Alan, for the record, Alan will be coming on next in about 5 minutes, but we've got about 5 more minutes left of some question time we can go through. Okay. So another question you got, it was actually directed at you, and it was sent before like this webinar actually happened. I noticed that your topic is for low code. Is GraphQL only good for low code projects?
Yeah, I think going back to this idea of the low code spectrum, I think that low code can kind of help take away some of the developer pain points or some of the developer productivity issues that we might experience. So you can certainly build GraphQL APIs with sort of that more traditional approach that I talked about at the beginning, where we're starting from type definitions, building resolvers. But the idea of low code comes in with tools like Neo4j GraphQL that really can accelerate and abstract away a lot of the boilerplate code that we need to think about. So I guess I see low code as kind of an accelerator for these types of projects.
Okay. Yeah, so I appreciate that answer. So I have one more question, and this is very like a general type of question, but I think you'd be pretty good at answering it. What made you pick GraphQL as I guess like opposed to like other options that are out there?
Yeah, so GraphQL was open sourced by Facebook in 2015 or 2016. And when it first came out, it was something that at Neo4j we were really interested in because of, one, it's an API and a common or a tool for building APIs, really. One of the common things you do with an API is talk to databases. So of course we're interested in it simply for that reason. But I think the concept of modeling your application data and exposing it to the client as a graph was extremely compelling for working with building your GraphQL backends using a graph database, because you have essentially that one-to-one mapping of how GraphQL is modeling and thinking of your data and how you're storing it in a graph database, which I think was a really powerful concept for us to dig into.
All right, nice. Well, okay, so I do appreciate you answering that question. That's pretty much all the time we got for Q&A. If other than that, do you have any last things you want to say before we go ahead and wrap up the session?
I don't think so. Just thanks everyone for joining and watching today. And thanks, Jamie, for organizing and hosting me.
Of course. Hey, William, hope you have a great rest of the day.
Cool. Thanks, folks.
Okay, so before we go ahead and move on to Allen, I want to go ahead and give like a quick little shout out to one of our partners again. If you enjoyed that GraphQL presentation from William, which was a great presentation, by the way, if you'd enjoyed that, please consider joining this meetup group dedicated to GraphQL. They have like regular events that are coming up, and they're worth checking out. Also, something I want to do real quick, I want to give a quick announcement for everyone that's like watching this. At the end of this presentation, we're actually giving out a certificate for people who are participating and watching this conference. So if you are interested in getting a certificate by the end of this presentation, stick around to the end and I will give you the instructions on how to acquire the certificate. All right. Now that I got that out of the way, I'm going to go ahead and bring Allen on board. All right. Hey, Allen.
Hey, everybody. Hey, Jamie. How are you doing?
Doing good. See, you still got that great background going on. So
I do. Even if I wanted to get rid of it, I couldn't. It's wallpapered back here. And then...
Oh, all right. So, Allen, if you could please do me a favor, for the people that do not know you, can you please give like a quick introduction as to who you are?
Absolutely. I actually have a slide for that in my presentation. But I'll say it before I get there. My name's Allen Helton. I'm a software engineering manager from Tyler Technologies. I got my start in software back in 2012 as an engineer, as a software developer, and I've worked my way up over the past 9 years to get to the point where I am now, which is managing serverless app teams at Tyler Tech, which is a very fun job, to say the least. So, my days consist of working with the fun tech stacks, AWS and all that, and building APIs and building them fast and making them reliable.
Nice. Well, I'll go ahead and let you get started. I'm looking forward to seeing how we're going to be taking serverless APIs and fine-tuning them. So I'll let you get started.
All right. Well, thank you again. Let me get all set here. Okay. So power tuning your serverless API. As I said, my name is Allen Helton. Work for Tyler Technologies as a software engineering manager. I won't go over all my bio stuff again. So I'm just going to jump straight into what we're going to talk about today. First, we're going to talk about serverless APIs, kind of in general, what they are, how they compare to server-full APIs, and what you would expect your architecture diagram to look like before versus after doing some of the power tuning we're going to talk about. We're going to learn how to identify issues. The big piece of power tuning specifically for happy customers is figuring out what to work on. You don't want to be focusing all of your attention on features in your API that aren't used. So we're going to figure out what benefits serverless has that we can identify and isolate the problem areas in our application. Next, we're going to talk about power tuning itself. What are the tweaks and the performance modifications that we can make that really enhance our APIs and make them shine, make them sing. And then lastly, we'll open it up for some questions. Before I go into anything, I'm going to put this up here as a disclaimer. Do not confuse unfamiliarity with complexity. So serverless it's still relatively young. It's not new by any means, but there's a lot of new things that come out pretty much daily with serverless in general. And a lot of people can confuse what they don't know with complexity. So I just want to put this disclaimer out there that what we're going to go over today is actually relatively simple. You just kind of have to give it time, even though on the surface it looks like a beast to go in and configure. I don't know who said this. I was having a conversation on Twitter with somebody like a year ago, and they threw this bomb out for me, and I can find the tweet to give them credit, but they are smart. So here we go. Let's talk about serverless APIs. At its most basic, this is a serverless API. I tend to joke, I make a lot of architecture diagrams for clients, and the joke I always make is maybe I'll just give them this and just say this times a lot, because a lot of times that really is what a serverless API looks like. What is this? What are these three icons that I have on the screen? Well, the first thing is your API gateway. This is a managed service from your cloud provider that receives requests and executes business logic and returns a response back to your consumer. You have your serverless function. So this is actually what's performing some of the business logic and doing the work in your API. And then you have, of course, your backend. Traditionally with serverless APIs, you get NoSQL databases. Doesn't have to be, but that seems to be the trend going with serverless APIs is going and having a NoSQL database. So that's basic, but let me show you what I would consider the intermediate, more real serverless API architecture that you see oftentimes out in the field. Now it looks pretty similar, but you see a lot more functions on the screen. You still have your API gateway up at the front, and it's still going to receive requests, execute business logic, and route responses back to the user. But what the distinction is here is that you have a function representing each individual endpoint. So for the duration of this presentation, I'm actually going to use an API for my fake business, Gopher Holes Unlimited. Let me toss some endpoints in here that just tracks gophers and gopher holes. So what we have here, you can see each one of my endpoints points to a serverless function. And then those all, of course, map back in the back end to a NoSQL database. And the big thing that I want to drive here, the big point that we want to specifically note, is that each specific endpoint has its own handler. So we're going to come back and touch on that a few times in this presentation. So let's take that, and then let's go and talk about what does a advanced one look like. What would a serverless API architecture look like after I've power tuned it? Well, it looks a little bit more complex, but the components are basically the same. You, of course, have your API gateway, and it has its routes, and it goes and it routes specific endpoints to specific proxies. And what's interesting to note here is that not all of the endpoints that you see on this graph go to a serverless function. Some of them go directly to Dynamo or to a NoSQL database. Some of them go to other services. The point being, you do not have to hit a serverless function with a serverless API. And of course, you also have managed services that the functions can call in the case that you want to make some of your operations asynchronous. You don't have to have synchronous operations in a serverless API. You can always return a 202 status code saying, I got your message, we're going to do something with it, please check back later. So we're going to come back again to the advanced serverless architecture. We're going to build our way up to something like this. Before we do that, I want to show what a traditional serverful API architecture looks like in the cloud. Looks relatively simple, and that's because it is. There's not as many moving parts as far as managed services go as with the serverless API. You, of course, have your API gateway up at the front, again, responsible for fielding the request and returning the response. You have load management, which is a little bit different than a serverless architecture. You have load balancers that point typically to an auto-scaling cluster that houses a bunch of containers, the containers running your API code. And then, of course, you have your database. Doesn't have to be NoSQL, could be a SQL database, doesn't ultimately matter what it is, but these are the major components that you'll see with a serverful API, and you can see how that differs from a serverless one. Now that we understand and are all on the same page on what a serverless versus a serverful API architecture looks like, we're going to dive into identifying issues and figuring out where our problem areas are. And as we all know, I'm sure everybody can relate with this, the easiest way to find where issues are in your API is to just wait. And what does that mean? You will get a phone call from an angry customer saying, hey, this doesn't work, or hey, it's unacceptable. And as we all know, unhappy customers are the absolute worst. So what we want to do is prevent those phone calls from coming in and switch our mindset to be proactive instead of reactive. Let's try to fix things before we get those phone calls, because those phone calls really aren't fun to field. I've had my fair share of unhappy customers, and I would prefer to catch problems before they happen, or at the very least before our customers see them. So what are the keys to happy API customers? We don't want them calling us on the phone, so we want to focus on two major components with our serverless APIs. One is speed, speed being just in general performance. How quickly are your endpoints responding? What's the average? What's the slowest? What's the fastest? And also reliability. Are your endpoints performing consistently? Do they perform under load? Do they give you the same result time after time after time again? Last thing anybody wants is an unreliable API where you can't trust it to A, come back with the same result, or B, come back with the results at all. But we really want to focus on high uptime and high performance. The first thing we're going to talk about with these two things is speed. So I'm going to throw some numbers up on the screen. And these are, in general, thresholds for average response times. If your API endpoints respond on average less than 500 milliseconds or half a second, then it's going to go unnoticed. It doesn't matter if it returns in 8 milliseconds or 499 milliseconds. To the user, it's going to feel the same. And that's just an expected behavior. They're not going to be specifically happy about it. But the good thing is they won't intentionally be angry. When you get a little bit more slower than that, between half a second and 1.2 seconds, your customers are going to get antsy. They might start clicking buttons again, wondering if they actually did click that submit button, or they're going to try to refresh the page, wondering if maybe something broke. So that's kind of your danger zone there. And if on average your API is responding less than or greater than 1.2 seconds or 1200 milliseconds, you have the worst API ever. Not my words, but the customer's words. They will tell you that. You have not built that trust with your customer if everything responds slower than 1.2 seconds. So what can we do about it? How do we know where in this zone our API falls? Well, we can measure performance, and we can measure performance in one of two ways. The first way is black box testing. So at the yellow line in the middle of the screen there, that's your API. Left-hand side is the internet. The right-hand side is the implementation of your API. And with black box testing, what happens is a request comes in and it gets returned, and you get how long did it take overall. I don't know what it's doing, but I can tell you that the average response time was 423 milliseconds when this API was running. And you can track that with a variety of different tools. If you're an Azure user, you can use Azure Monitor. If you're an AWS user, you can use AWS CloudWatch. You can even use external tools completely separate from your cloud provider, like Postman. Postman being a tool that you can use to test your APIs, and it gives you things like average response time. On the flip side of this, we can do white box testing. White box testing meaning I know exactly what's going on in your API, and I can tell you exactly what's going on at each step. So what that would look like, if a request comes in, it pieces out each one of the managed services or areas that your API is going through. So in this case, we had API gateway, we had a function, we had the database, and then we had external storage as well. Each one of those piecing together, ultimately resulting in that 423 milliseconds. So both black box and white box testing are valid ways to get to how fast are my endpoints running. It's really up to you to how fine-grained detail you want to get. Of course, you also have monitoring tools for this. So you have the Azure App Insights. If you're an Azure user, you have AWS X-Ray. And then once again, there are external tools completely separate from your cloud provider, like Datadog, that you can instrument in your serverless API. You get this kind of insights. Now let's go and talk about what do I get for free, these automatic analytics, because I use serverless. Well, I get duration. I get to know whether I'm doing black box or white box testing. I get to know on average what was the response time of my API. Also, what was the slowest? What was the P99? I also get the fastest if I care. I get things like counts. How many times are my endpoints getting called over a certain period of time? Do I get more counts in the morning versus the evening? Is it evenly distributed? What are the counts? And lastly, another thing that matters, that's a really big deal, are success rates. You would really want to know with your APIs, if you're constantly throwing 400s or 500s, you always, of course, want to aim for successful responses. And you always want to make sure that you keep track of your average success rate. And one of the big benefits that we get for free because we use serverless as our API is that we get all three of these metrics per endpoint. So I can know on average, this specific, when I add a gopher into the system, I can see that it's this fast. I can see that it gets hit this many times and that it fails that many times. Let me show you what you can actually do with these metrics when it's broken down by endpoint. You can see on here, I have a graph, and the graph has 4 random endpoints that I've selected from my API, and it's broken down by these 3 metrics. How many times is it being invoked? What's the average duration? And how often is it failing? And you can see that it's very different across my API. On the left-hand side, you can see that I have my post to add a new gopher into the system. It's called a lot. It's called more than anything else, and it's blazing fast, and it rarely ever errors. Conversely, my get gophers, so I'm trying to load all the gophers in the system, it's called a decent amount. It's not as much as the other one, but it's kind of slow, and it also errors a bunch. And you can see the other ones. If I'm trying to update a gopher, it's not called very often at all, but when it is very slow. So what I can do, or what anybody can do, is really set priorities based on this information. And you can see that I really should put my #1 attention and focus on that get gophers, because it's called a lot and it's kind of slow and it errors a bunch. So that should be getting my attention, because that's where my customers are likely getting hangups. Same with the post for getting gophers. I probably don't need to pay attention to that. I need to focus my efforts in these other 3. And if those get all squared away, maybe then I can go and address the errors in the post. All right, now what we're here specifically to talk about is power tuning. So we've learned how to correctly identify where your priorities should be. Now we're going to figure out, what do I need to do to improve those specific endpoints that are my problem areas? Here we go. So I brought back our intermediate, let's say, starting point serverless API. And by default, your functions, they have a set number of memory or RAM that they can use and can allocate, and they're not allowed to go above that. One thing that you can do that's almost 0 effort is just throw more memory at it. Just say, okay, this function, let's bump up the memory. Let's give it some more power, and you will immediately see benefits. It will actually start running faster with little to no effort, no code change. Really, if you're doing infrastructure as code, it's just changing a declarative value and upping that. But one thing that I want to mention is that you really need to find a balance. More does not always equal faster. You'll reach a point of diminishing returns where you can keep bumping up that memory, but it's just not going to get any faster. Ultimately, what you're doing is you're just driving your bill up, because you're going to be paying for resources that aren't improving the performance of your serverless API. So let's take the concept of being able to improve the performance of a specific endpoint of my specific problem area, and let's toss that in and show what you would do currently if you're using a serverful implementation, what that would entail in. What is the difference between what I just said and a traditional backend API? So you have your serverful endpoints here. Everything, all the endpoints are routed toward the cluster of your EC2 containers or your Linux machines. And instead of showing RAM, I have an instance size over there. You see M4 large. So if I wanted to go and I wanted to increase the resources on that backend API, I'm actually just going to be changing the instance size, which means everything gets the benefit of the more resources out of the box. But that also probably means that I'm going to be paying for stuff that I don't necessarily need. So if some of the endpoints will get more resources when they don't need more resources. Everything is shared across all my different endpoints, so I don't get that fine-grained power tune. Okay, coming back. Let's go back to serverless. That's what we're here to talk about. We have here something that we need to specifically look at when it comes to the actual implementation of our API. We talked about adjusting the resources, but now what we're going to do is look to see, are there any shortcuts that we can take? Keep an eye out for any of your endpoints that are just doing transforms. Am I loading data from the database and just spitting it back out to the user? If so, that's a great candidate to just go direct. You don't have to run a function in order for an API to return results. I can cut out the middleman and go straight to the database to pull that data and display it back to my user. Now that sounds great. And the first time I heard that, I thought that was the best thing. So I thought that I would show you, what does that actually look like? In the definition file of my API, we always use Open API spec to define our APIs. We can add in here a query. For AWS, it uses VTL to go in, query the table, and then format the results and bring them back to the user. It doesn't matter if you're using AWS and connecting to Dynamo, or if you're using Azure and connecting to Cosmos DB. Both cloud providers offer this, so you're able to cut out that middleman. So let's say you go to the extreme and you learn all of the managed services that you can go straight to, and you change your diagram and it looks like this. We've cut out several functions that were unnecessary. We've increased our speed, and we've brought it all to look nice and advanced like this. What are the benefits of doing that? Well, firstly, you have fewer moving parts. And as we all know, the fewer moving parts, the less code you have, the less likelihood you're going to introduce bugs. Less code is better, ultimately, when you're talking about systems design. You have increased reliability by making a performance change. In the very unlikely instance that something like Lambda goes down in AWS, all of your endpoints that don't use Lambda will be okay. We'll likely have is a lot more to worry about if something like Lambda goes down, but at the very least, there will be a few endpoints in your API that are still going to work in that case. Lastly, it's blazing fast. If you're using NoSQL for the backend, I tend to see single-digit millisecond response times. So if you're proxying straight from your API gateway to the database, you're going to get incredibly fast response times. You don't have to wait for anything. It's just grabbing it and returning it. We're going to focus now on reliability. And when I say reliability, what do I mean? Well, I actually mean two things. There are two things that determine the reliability of your API. You want to make sure that your API is fault tolerant, meaning if something bad goes wrong, what does it do? And you also want to consider how your API performs under load. If you guys are familiar with Reddit, a lot of times what happens when a small company posts their website on Reddit and it goes viral, a lot of people will go in and go to their website, and what Reddit refers to as the Reddit hug of death happens. The burst traffic overwhelms the servers on these low websites and just takes the whole thing down. And in my opinion, that is not a very reliable website or API if it's taken down from burst traffic. And that's something that we can actually do there are things that we can do to make that not happen with serverless APIs. Let's talk about that a little bit. So instead of endpoint tuning, here we go. We're gonna talk about reliability tuning. So I have our current diagram up of our serverless architecture. And one of the first things that we can do when it comes to reliability is implement something called provision concurrency. And what that means is for any of these high traffic endpoints, I can say I always want X number of functions warm and ready to go and ready to respond to traffic. If we update our diagram, that would kind of look like this, where an endpoint has all of these functions hot and ready to respond, which means I don't have to wait for cold starts. It's something that is for critical API endpoints, things like CAD, the computer-aided dispatch, things that have to respond really at the drop of a dime, are very good candidates for provision concurrency. It's also good for scenarios where you get burst traffic. So I like to think about burst traffic and relate that to the sewer system during the Super Bowl. When halftime rolls around at the Super Bowl, everybody races off to the bathroom because they've been holding it because they want to see the football game and they want to see the commercials. And as soon as the halftime show starts, everybody races to the toilet, uses the bathroom at the same time, flushes at the same time, and the sewers just get swamped with everybody flushing at the same time. It's kind of what happens in some scenarios with APIs. There will be instances where you just get an overwhelming amount of traffic that at a single point in time. And when you do provision concurrency, you can handle that very, very easy. It's also something that can scale with demand. The other part of reliability that I want to talk about today is something called, or really just for redundant deployments. It's deploying your same infrastructure in multiple regions. It doesn't matter if you're using AWS or if you're using Azure. All the cloud providers have regions where you can deploy your code, and those are located geographically in different areas around the world to serve specific customers. Having redundant deployments out there is going to provide you with failover. Let's say a region goes down. You can automatically route to a different region that's up, keeping your reliability high because your API isn't down. You can also get a performance boost from doing something like this. You can do DNS mappings based on geolocation. So the IP address comes in of a requester, and you can say, okay, well, based on that, I'm going to send this over to this region because it's located geographically closer. I live in Texas, so all the stuff that I send over to my cloud provider routes me over to the east side of the United States to serve. But if somebody from Mumbai, India comes in, they're not going to want to go to the east side of the US. They're going to want to go to a Mumbai region. So we can do that with our DNS mappings based on geolocation or ping or health checks, just to make sure that we don't send somebody to an API that is down. A good point to note, this is actually not unique to a serverless API. This is something you can absolutely do and should do with a traditional API. If you're deploying it into the cloud, it doesn't matter if it's serverless or if you're using containers. You should always do this to improve your reliability. All right, go back. I want to go over real quick, what have we learned today? What are the things that we can do to power tune our serverless APIs? First thing we're going to do, we're going to figure out how to identify our problem areas. So that means we're going to figure out which endpoints specifically are invoked a lot, are slow, have high failure rates. We're going to figure out which ones need to be tuned. One of the things that we can do based on that is boost the resources. The little to no effort technique that we can do is just allocate more resources to it. Let's try that, see if it succeeds, and we're good. Next thing we can do is go straight to the source, meaning we don't have to run a function. We can go straight to the database. We can go straight to a queue. We can go straight to async operations. So customers don't have to wait if we have a heavy endpoint. And lastly, we can add provision concurrency. We can go in and say, this always needs to be ready and handle burst traffic if we need to. All right, so with all these different things, you're going to take your serverless API structure from what we've seen here to something a little bit closer to this, where we have our endpoints that route specifically to different managed services. We have some endpoints that have more resources allocated to them specifically. We have some other endpoints that have a lot of provision concurrency because it's run all the time. And we also have some that hit async services and just return. Something that will really greatly improve the performance of your API and ultimately your website. We can go from this, and then if we go to the extreme, we can just take that, deploy it into multiple regions, and then start routing people to specific regions based on where they're located geographically in the world. Something like that will give you a fully power-tuned serverless API. Very exciting. Sounds very complicated, but it's actually relatively simple to do. We can go in there. It just takes a little bit of conscious effort. Let's take a look at what we've built, figure out what needs help, and give it some of that help. So with that, I'm ready for some questions. What do you guys have for me?
Sorry, my the button to get joined on wasn't wanting to work for some reason. But yeah. So Alan, thank you so much for giving that presentation. I do have collected like 2 questions that you got. One of the questions, and I really like this one. Out of all the ways in your presentation to fine-tune your serverless API, what suggestion do you feel is the most important?
That's a great question. You will get the most bang out of your buck if you start going straight to services that are not serverless functions. The reason being is because you cut out that middleman, and you get multiple benefits for that. You don't have to write code, really. You're writing significantly less code. You're cutting out hops, which means it's just going to run faster anyway. And one of my favorite things is if you're not writing code to do that transformation, you don't have to write unit tests. You don't have to maintain unit tests. You don't have to maintain all that code. It's easier, really, ultimately for everybody in the future if you do it that way. You're just writing a very short script to do a data transform, and you're off to the races.
All right. So another question that we ended up getting, I feel like you kind of answered this kind of already a little bit in your presentation, but kind of go a little bit more in depth with it. Can serverless APIs ever compete in terms of low latency with a traditional backend service behind a load balancer?
I think that they can. And really, it's with a combination of the things that I spoke about in this presentation, you can match some of those latency times. One of the things that everybody brings up is, oh, you're doing serverless. What do you do about the cold start times? Well, there's an answer for that now, and that's provision concurrency. Yes, you have to pay for it, but if it's really that important to not have that latency, it's worth the money. You can have the provision concurrency. You can up the speed and the allocated resources to the function and make it perform just as fast as if it was a container that's always running in the back end. Plus, if you cut out that middle layer entirely and just go straight to the source and return, it's actually probably going to run faster because there are no cold start times because there's nothing to cold start.
Okay. So I do have like one more question before we go ahead and move on to Keith, who will be our final speaker. As far as mistakes that can go from like building APIs for customers, what do you feel are some of the more like common mistakes that occur when building APIs for customers that you would, that you most commonly see, and like how would you recommend avoiding them?
That is a good question. There's so many different ways that you can go, but what I'll do is I'll talk about it strictly from a performance point of view. It's real easy to forget to change allocated resources from the defaults. The developers are focused on hitting timelines and solving the business problems that they forget that, yeah, this is actually a pretty heavy function. It's doing a lot. I should allocate a lot of resources to this. I don't need to use the default. I need to give it a full core on whatever machine it's going to end up running on to get the quickest response times possible. Or maybe I don't need to await an async operation. Maybe I can, fire and forget it. It doesn't actually matter. I don't care about the response. Things like that are real easy to forget, that if you're just new to serverless, it's not something that you'd even think about to do. It's not stuff that typical developers typically think about. Is what do I need to do to make this run faster in the cloud?
All right. Well, Alan, that was a great presentation. Thank you so much for coming on and presenting and providing more education for the community. So before I go ahead and move on to Keith, do you have any last things you want to say before we wrap up?
I do not. I appreciate the time. I hope you guys liked what I had. Thank you very much. Always open to questions. If you guys have anything specific, you can send me a message on Twitter or reach me on LinkedIn.
Nice. Well, hey, Alan, hope you have a great rest of the day.
Thank you very much. You too.
All right, so next we're going to go ahead and bring on our last speaker, which will be Keith. All right, hey Keith, how you doing?
Hey, pretty good. How are you doing today?
Doing good. So you're going to be the last speaker for this event, and I really appreciate you coming on. So for people that don't know who you are, could you please give like a brief little introduction?
Yeah, absolutely. Hey, everybody, I'm Keith Casey. I'm the API problem solver at Okta. I live and breathe our APIs, and I've worked in the API space for, longer than I care to admit. I think it's roughly 20 years at this point. So been there, done that, got the t-shirt, got many t-shirts, and happy to be here today.
Nice. By the way, I know I said this to you before, but I love your job title, API problem solver. Like, so many times with like job titles, it's like, what does that guy actually do? You know, how do you describe that title?
Yes.
API problem solver. That's straightforward. So
yes. Yeah, it was when I first joined the company, I stuck that on my business card and no one challenged it. So it must be true.
Okay, that's all right. So I'm gonna go ahead and add your stream to the live chat. I'll let you go ahead and present your slides.
All right, fantastic.
All right, cool.
All set there?
Yep, you're all set. I'll let you get started.
All right. Hello, welcome everybody. Like I said, I'm Keith Casey, and today I'm here to talk about API security strategy. When we think about APIs, when we design APIs from the ground up, we've kind of mastered the basics. We've mastered whether it's REST or GraphQL or whatever. We've mastered all those. What we haven't mastered is how we secure them and how we think about them. And we've kind of been lulled into the sense of false confidence. So that also leads to the subtitle of my presentation of when failure looks like success. That's the most seductive and dangerous position of all. But quick intro on myself. I'm from the great state of Texas. If you're not familiar with Texas, I know Allen was. I live right near that dot where the white, the red, and the blue meet, near Austin, Texas. And the cool thing about Austin is you can drive 6 hours in any direction and you're still in Texas. That's how big it is here. In fact, Texas is so big, you could take other land masses and actually put them inside Texas and they'll fit. I'm not going to tell you which one of these is true, but maybe some of them are. But seriously though, I work for a company called Okta. We do single sign-on identity management. My specific product is API access management. It's thinking about OAuth as a service fundamentally. Prior to that, I was at a little company called Twilio, and I say little because when I joined up, it was about 25 people, and had a blast there early days when we all fit in the one conference room. And in between there, I was at a company called Clarify, where we were building APIs to make audio and video searchable. That's since closed down, but I've lived and breathed these APIs for so long that eventually found a lot of common patterns, a lot of common structures. So wrote a book on API design with my good buddy James. And we know it's the best book on API design because it is the APIdesignbook.com. But seriously, let's dive into APIs. So usually when I talk to groups, I'm talking to a good number of suits. And by suits, you know who I'm talking about, the business users, the people who wear suits. Even now on Zoom calls, they're wearing collared shirts and jackets. If they're very unlucky, they're wearing ties. They're still trying to figure out what these APIs are for the most part and trying to figure out how they connect together. But they're not just thinking about it at an individual API basis. They're thinking about it at an organizational standpoint. So I always have to tell them about the API economy. And the way I describe APIs to them is I say an API is how one piece of software talks to another piece of software. That's it. Now, there's tons of nuance in there. We could talk about SOAP. Please don't. We could talk about REST. We could talk about GraphQL. We could talk about HTTP verbs. We could talk about all these things. None of that matters at this level. It's how one piece of software talks to another piece of software. And they talk primarily so that they can exchange data or share functionality. And so if you think about how APIs, all the primary use cases for APIs, that's what they all boil down to. They're sharing data or they're sharing functionality. And that's about it. So when you talk to your own business users and they say API, I can barely spell that. Take a deep breath, I get it. And then say, okay, look, it's how one piece of software talks to another piece of software. It's how we share data or functionality. And sharing those things is way better because now we can potentially charge for it. We can reduce duplication in our systems. We can do a lot of things as a result. And so one great example I always share with customers and everyone is Experian. Experian in the US is a credit reporting service. They say, how good is this person paying their debts? Okay, pretty straightforward. If you've ever bought a car, you know that's a miserable experience. You walk into the dealership, you say, I want to test drive a car. You go test drive the car. You give them your driver's license. They scan that. They try and figure out who you are, all this kind of stuff. And it ends up taking hours and hours and hours if you actually want to buy the car. So the vision, the value of APIs in this case is that Experian has a number of internal developers, and they've made these APIs accessible and usable to everyone inside. But then they also open up their systems to external developers. And when we start thinking about that, we can streamline this entire process. So the mindset starts with, well, now these third-party developers, maybe from Toyota, maybe just a startup, can now pull data from Experian. There's that sharing that data. Then use that data to hit Capital One's API and say, what loans do you qualify for? There's another sharing of that data. And then they can go to Geico and they can say, okay, well, let me make sure you can get insurance on this car you just financed with this data that we just had. And so a process that used to take hours can now collapse to minutes. This is amazing. This is where we want to go. This is the real value of APIs. We all love the sexy examples of Uber and Twilio and things like that. But this is the kind of thing where it makes more and more people's lives tangibly easier, and it makes business situations less prone to error. Both good things to do. We have a problem though. And this gets into how we design and we build and we think about our APIs. So in the right-hand group there, we have our developers. These are usually the back-end developers building big systems, and they build our APIs. And I'm one of in that group. So the problem we have here is developers have exactly two goals in life: build something useful and go home. That's it. Now I know everyone's saying, well, I don't want to go home. I want to go do this. I want to go to the pub. Whatever. It's about leaving the office. It's about being done with your work for the day and moving on to something fun. Whether that something fun is your side project, whether that's just going out in the woods and enjoying camping, whether that's spending time with the kids, I don't care. It's build something useful and go home. Integration architects on the other side have a very similar mindset. These are the front-end developers. They're the ones that pull together these wonderful APIs we've built. And they also have two goals in life: build something useful and go home. Now, most of what they build is going to be more customer facing. So they have some other concerns in there. Useful in their definition doesn't mean necessarily performant. It means, does the UX solve the customer's problems? So a little bit of difference in definition, but not much. Then we have the security architects in the middle. The security architects in the middle have exactly one goal in life, and that's to say no. Actually, that's not very fair. I'm sorry for our security architects in the group here. Security architects have a very special job. Their job, their whole focus, their entire purpose for being employed at our organizations is to protect the organization. So they look at the developers on one side and the integration architects on the other, and they say, you guys are cowboys. I don't know what you're doing. I have no insight on what you're doing. Bad things are going to happen because you're going to screw it up, and it's going to be my butt on the line. So we end up with these three groups. They're generally at war with each other. Developers want to move fast. They want to ship code. They want to ship more useful code today than they did yesterday. Integration architects have a very similar interest, but usually they're annoyed at the back-end developers for the API not being exactly the way they want. And the security architects hate everybody. That's a little extreme, but they're generally very upset. I mean, that's fair because the developers and integration architects are also upset at them. This is a bad dynamic. These are one of the things that we have to change. It doesn't change with happy hours. It doesn't change by having yet another meeting. It changes by changing our mindset. We have to stop and think as developers, whichever side we're on here, whether it's internal or back end or front end, we need to change our mindset and realize the problems that security architects are dealing with and that they're solving are valid, and we can make their lives easier. So let's talk about that. When we actually look around the industry as a whole, APIs are becoming a #1 attack vector. This is a quote from Gartner. I believe it's about a year old now. I think this is optimistic. I think we're already well past this. I think the API vector of attack is the most common by far, and it's the most devastating by far. But so far, we haven't talked about failure. So let's. Now, failure here is kind of obvious and subtle at the same time. So the obvious ones, these are the breaches that have happened in the last, say 3 or 4 years. Most people are familiar with the Equifax breach that breached, I think, every adult American. That was a cool one. Some people are familiar with the British Airways breach. They actually had an application where you could pull up people's passport information. That resulted in the largest single fine under GDPR to date. I believe it was 180 million pounds. So I think it translated to about $250 million fine as a one-time fine. Then there's an app called Tinder. You might call it a dating app. I think that's a fair definition. They had a breach in their API that allowed you to receive and send messages as anyone else in the system. You see that, how that could be a problem. Now, the thing, I'm not making fun of any of these people. I'm not challenging them. I'm not saying they were foolish in any decisions they made, though you may want to, I get that. What I'm trying to say here is every organization, regardless of geography, regardless of industry, regardless of size, is a target. You are one. You are absolutely one. You may not realize it yet, but let's talk about that. So the good news with this is that most of us aren't building bad APIs on purpose. The way most APIs come about is because us as a team, you know, you've got your team of 4 or 5 other developers, you're building something useful. You build something useful once and then you build it again, and you build it again, and you build it again. And at some point you realize, wait a minute, my goals in life are to build something useful, which I am, and go home. Building the same thing over and over again won't let you go home early. So we build an API because we say, instead of building this 5 more times, I'm going to build it once and then share this data, share this functionality with other people on my team. Now I build it once, I maintain it once, everyone's happy. Everyone goes home on time, they hit the pub, whatever the case may be. Well, now here, success breeds success. Because we build this API, now we're going home on time and everyone on our team is happier, healthier, all those sorts of things. Well, that team down the hall hears about it. And when that team down the hall hears about it, they say, hey, I heard you have this great API. We have a very similar use case. Can we use it? And of course we say yes, because the way we measure useful is often how many people are using our stuff. So we have to start thinking about versioning. We have to start thinking about internal collaboration. And in fact, once we realize other people in our company value our API, odds are we're going to start promoting it. We're going to talk about it everywhere. We're going to talk about it in our one-on-ones. When we go for that raise, we're going to talk about how much time and effort we saved everyone in the company. So we're going to celebrate this. And so we go from 5 people using our API to 5 teams using our API. And that's great. We should be excited about that. Well, eventually, VPs, maybe C-level executives hear about this API and they hear about the things that we're doing with and how we're solving problems. And they say, oh, wait a second. We actually have partners. We have suppliers. We have our top tier customers who have very similar problems. Can they use the API? And we say, yes, more people using our API is a great thing. We're very excited about that. Please use our API. So we take the docs that we had to improve earlier, and we share those. We share access to it. We open up ports and firewalls. Maybe we share resources, whatever the case may be. And now we've moved from 5 people to 5 teams to 5 organizations using our API. But that's great. We're successful. We're very happy about this. Then at some point, the C-level exec, most likely the CEO, talks about digital transformation. And they say, we're not just a company that uses APIs. We are an API first company. If you're a C-level exec here, I'm sorry, I'm going to make fun of you. It's just how it works. But we're an API first company. And in fact, we're going to use this API to address new markets, to solve new problems, to drive direct revenue through our API. And we're going to launch this API to the world. In fact, we're going to launch this API to the world in a month. So look at our progression here. At phase 0, we could look around the room, or we could all be on one Zoom call and see everyone using our API. Odds are we can name them. At phase 1, this expanded out to 5 teams. So we may not be able to name the people, but we can name the teams. At phase 2, we went to organizations. So we may not be able to name the teams, but we can name the organizations that have access to this. Phase 3, it's literally anyone in the world. if the hair on the back of your neck is standing up. I completely understand, because at this point, the CEO is going to go to the security team and they're going to say, hey, security team, we're launching this API in 30 days. We need you to go through and validate it, vet it, hammer on it, make sure this API is secure. But don't worry, we know it's pretty secure already. We've been using it for a year. The security team hears exactly one thing in that statement. We know it's secure. We've been using it for a year. Now, the more clueful people on this call realize that just because you're using it doesn't mean it's secure. Those two phrases are completely disconnected, but somehow we connected them there. Because as the security team digs in, let's be honest, we know they're going to find vulnerabilities. We know they're going to find issues. And in fact, any issue they find at this point has actually been there the whole time. So now our security team has to go to the CEO. And they say, excuse me, CEO, so that API you wanted to launch, there's a problem. And now there's only two things they can say here. Either A, there's some issues, but let's launch it anyway. Now remember, when there's a breach, no one's going to come back to the team that built the API. They're going to go to the security team, and they're going to have a bad day. Or B, the security team can say, we can't launch in 30 days. We need to go back and change the API. We need to put some security in place. Both of those are really bad answers. We've set up a situation where now the security team has to suffer all the consequences of every bad or just misinformed decision that we made everywhere in this process. Because if we go back and we add API keys or OAuth or whatever, we change the security architecture of our API. Think of how many people have to change their applications at this stage. It's your entire team. It's all the teams who used your API. It's all the partners, resellers, customers, suppliers, and everyone who also use that API. And it's anyone else in that early beta release stage, those early access customers externally. Security team just gave us a really bad situation. No, actually, let me rephrase that. Security team just pointed at a really bad situation that we created. And that sucks. This is why the security team is always hated, because they're always the one that delivers bad news. Now, we created that bad news, but they had to deliver it. So how do we get to be friends with our security team? How do we make this easier? How do we make this better? Fundamentally, how do we secure our APIs? So let's go back to the drawing board. Let's go back to base principles. When we're at phase 0, we're trying to launch that API for the initial group just to see how it works and everything like that. What questions should we ask then? What principles should we bake in? I always say there's 3 that are really easy to consider. Let's only expose the interfaces we need. Not a big surprise there. Let's see, let's only collect and share the data we need. Okay, yeah, just because you collect data doesn't mean you need to share it back by the API. And 3, only grant access to the people and systems we need. Now, if you're like most developers at this point, you're saying, yes, Keith, I get it, that's security. You're right, we forgot one. I'm a software developer. We don't start counting at 1, we start counting at 0. So let's get rid of these and reset. Aspect 0, I want you to think like a bad guy. This is where things get fun. This is where things become a really powerful tool. This is where you become a multiplier in what you're doing. The problem is most of us don't like thinking like a bad guy. Fundamentally, we're pretty good, or at least chaotic neutral. We try to think about things in the good ways. We try to think about what's the happy path? How are we going to make sure things work for everyone involved? So I understand most of you aren't good at thinking like a bad guy. I get it. So let's figure out how. I always say, first, read the news. Look at what's happening to your competitors. If you don't have any competitors, look at what happened to Equifax. Dig into the technical analysis of those things and see what's happening. Next up, talk to your legal and compliance teams. Now, don't go to your corporate attorney and say, hey, what would happen if we had a breach? You're going to drive their blood pressure through the roof. Instead, what you say is, hey, look, we're considering scenarios of what would happen if our data was breached. Can you tell us some of the consequences that would happen as a result of that? So then you're very clearly upfront framing this as an investigative exercise, not a cleanup situation. okay? And you might still have a high blood pressure on the other side, but at least you've tried to do your part. Next up, talk to your developers about their horror stories. Every developer has horror stories about fast companies they've worked at, bad practices they've done. My favorite is about 15 years ago or so, I worked for a company, and to log into every system, you use your employee ID, which was printed on your badge that you had to wear, and the last 4 digits of your social security number. Yeah. Okay. And the last thing I want to do is write a Black Mirror episode. If you're not familiar with Black Mirror, it's a futurist dystopian television series where it takes an existing set of technologies or some existing concepts, and they take it one step too far. It may be the next logical, rational step, but it is one step too far. So write a Black Mirror episode of how would somebody misuse and abuse the data or the functionality we're sharing in dark and evil ways. Build up to that one though. That one's fun. All right. But to be able to do this, we need to not just think like a bad guy, we need to understand what their motivations are. What are they actually going for in this process? So what does a bad guy want? Obviously valuable data, yes, okay. We also want accessible infrastructure. Accessible infrastructure is great because maybe you're not the target. Maybe you're just a convenient jumping off point to the actual target. Next up, most bad guys want simple or no authentication or authorization. And this means simple usernames and passwords. I won't call out of the companies I named earlier on that failure slide. One of them had a username and password of admin. Don't do that. Next up, lots of bad guys like custom developed auth systems. Remember, as great as your team is, as great as you are personally, you probably haven't thought through every edge case that is out there. So don't try to build your own. And when I say auth there, I mean both authentication and authorization. If you think that you've come up with a great new hashing algorithm that's going to beat everybody else and is totally unbreakable, no, you probably haven't. Let's just be honest. Please use an existing system that's been vetted, been proven, whether it's open source or it's a company like Okta, I don't care. Your systems will be better as a result. Just make sure it's been vetted. And last up, bad guys want to act undetected. If you dig into the Marriott breach, for example, the attackers had access for about 5 years. In 5 years, you could do anything. If you look at the SolarWinds breach from last year, they believe the attack started in March and wasn't detected until December. In 9 months, an attacker can do a lot of things. And they've got time to clean up all their messes. So this is what a bad guy wants to do. Now, very rarely, or other than the first bullet point, none of this requires you to be the target system or the target organization. So if you think, well, I don't have any sense information, I don't have billing or medical data, well, okay, maybe you don't, but maybe somebody else nearby or maybe a partner that you work with does. So remember, it's not just about stealing the data you have. It might be about coming in from the IP address you do have. So think about it in that sort of terms. So to make this concrete for a moment, I always say use an API gateway. It's a very simple, easy process. An API gateway is great because you can make rules on the perimeter outside your API itself, outside the microservices or the serverless architecture you have itself, and filter that traffic on the boundary. That's a good place to be because now that's not additional load on your services. And if you're paying per transaction or per second or millisecond transaction fees, simplifying that and reducing that is going to not only save you time and stress, but it's going to save you money. Next up, let's be smarter about data. This is the one that drives me up the wall. If you don't need to collect the data, don't. The data can't be stolen from you if you don't have it. It's really that simple. The flip side of that is when you do need to collect the data, make sure it's secured in flight, it's encrypted at rest, and maybe you don't need to make it available again via API. Maybe that's not how you want to expose it. Now, most people, when they encrypt it at rest, they think, oh, well, as long as it's encrypted, it's fine. I'm not going to name the company, but there was an organization that had billing information, like credit card information, things like that, and they did encrypt it at rest. The problem is the encryption key itself was actually stored with the data. It was the digital equivalent of a Post-it note on your monitor. Don't do that. And if you find organizations that do it, if your organization does that, please stop. The consequences for that are going to be catastrophic. And yeah, you just don't, that's not a habit you want to develop. All right, and next up, we want to stick to the standards. This goes back to not creating your own protocols, not creating your own creations. Obviously, I'm heavily biased towards OAuth 2.0. It's not perfect, it's not easy, but it's well vetted. It has figured out a lot of those scenarios. It's figured out a lot of approaches to be able to say, okay, well, in these scenarios, here's what you do. Regardless of how, like I said, regardless of how great you are, how great your team is, this probably isn't where you want to spend your time. Even if you could do it well, odds are your application, your organization probably does more than sharing OAuth tokens. So how about you focus on that and then use existing protocols behind the scenes? Like I said, whether that's open source or that's Okta or whatever, I don't care. Well, I'm biased, but I don't care. I want you to build more secure software as a result. I want you to focus on what makes your software useful. Because if you dive into OAuth, it's a big, hairy mess. These are the top 12-ish or 15-ish different RFCs out there that extend OAuth. There's a ton of additional ones that are still under negotiation right now. In fact, I think this is out of date because I think there was one more established last month. But this is the kind of thing that you don't want to have to work through all these. And next up and last off, you need to plug into your existing processes. And I don't mean your existing processes like CI/CD pipelines and things like that. I mean existing processes that your security team has. And the best concrete example I have of this is T-Mobile. So about 2.5 years ago, T-Mobile was breached. Some attackers started downloading all their customer data. If we stop the story there, it's a terrible story. It's an awful story. There is no upside whatsoever. But that's not where the story ends. Instead, the API team worked tightly with the security team. And the security team had monitoring set up for the API. And so when these attackers came in and they found a vulnerability in the API, the security team was monitoring everything and said, whoa, wait a second. This is not an expected behavior. Let's shut down access. So instead of 77 million customer records being breached, it was only 3% of the data roughly. Now, 3% is still worse than 0. So I'm not celebrating that aspect. I'm celebrating the fact that the security team and development team worked closely together. And as a result of that collaboration, cybersecurity team could actually stop an attack in progress. And so now only 3% of their customers had a problem as opposed to 100%. I actually met one of the people on the team. I presented this particular slide a couple years ago, and I saw a hand shoot up at the back of the room. And I was like, yeah. He's like, yeah, that's my team. And I was like, oh, cool. Thinking he was one of the developers. He came up to me afterwards. He's like, no, my boss was the one that detected the problem, and then we shut it down. That was like high five worthy celebration there. That's the kind of thing that we want to be able to say, look, guys, when we work together, we can help each other. Security is a team sport. We don't have to be out there alone. We don't have to solve our problems alone. There are existing processes that can help us. So developers, when you're designing and building that API, plugging into the security team and their systems will make your system better. It will make your system not necessarily more secure, but more aware of what's going on in the ecosystem. And you can bet that the security team fundamentally saved the developer team's butts on this one. And that's a good place to be. Buy them beer, celebrate that, however you do that, but make sure that you're working together. We don't have to be enemies here. So that I want to leave you with a handful of closing thoughts. This has been a lot of material. There's a lot of failure out there. If I just went into the case studies of these different failures, we could go on for a while. We're not going to, because that would be mean, even if it'd be amusing. So some closing thoughts. These are some questions I want you to ask yourself and for you to filter around your team and to think about. First of all, what's the worst thing someone can do with our API? Look at what's happening to competitors. Look at what your own team has struggled with at other organizations. What's the worst thing somebody can do with it? And what are the consequences of that? Next up, what happens if our competitors get our data? My co-author on the book was working with a hotel chain here in the US. And when he was pulling back data from search results, there was a PID in the data. And it was just some sort of identifier. It was a numeric thing. And it was irritating because he didn't know what it was. He asked me, I was like, I don't know. So finally he went back and he was talking to the security team, or I'm sorry, the development team on staff over there. He said, hey, what's this PID for? And they dug around, they finally figured out, oh, that's a network-wide, as in across all the hotels. It's a network-wide popularity ranking for this particular hotel. So he said, well, if I'm a competitor and I can hit your API, your public API, and know how popular hotels are, could I change prices based on that? We need to remember that there are people hitting our API. There are people exploring our API. In some cases, they're going to be able to explore it and maybe do nasty things. Maybe they just want to download our entire product database. Regardless, we need to think about what happens when our competitors get our data. What are the consequences of that? Next up, we need to think about what data do we need to collect? On the flip side, what do we need to expose? Just because we collect it doesn't mean we need to expose it. At Okta, one of the things we're a single sign-on provider. So one of the things we collect when you create a new user is password. And we hash it and secure it and everything like that. We've had lots of requests of, well, can we just get the hashed password back out via the API? No, it's not that we're uninterested in doing that. It's that it's less secure if we do that. If you could, as a disgruntled user, hit an API and download everyone's hashed password, now it's just a matter of computing resources to be able to beat those hashes. Now, granted, with the current technology and processor speed and everything, that's probably measured in years, but I don't know what's going to be released next month. I don't know what new algorithms and approaches are going to happen. So if you don't need to expose that data, well, first, if you don't need to collect the data, don't. If you don't have it, it can't be stolen. Second, if you need to, if you don't need to expose it, don't. Your life will be easier as a result. Next up, we need to ask who our users are now and who they'll be in a year. If we have success when we're at 5 people, and success when we go to 5 teams, and success when we go to 5 organizations, we should assume that eventually our API is going to make it to everyone. The upside of thinking about this early is we can start thinking about what are the good security practices now, because you may trust everyone on your team. I hope you do trust everyone on your team. I think that's important, but you may not trust that team down the hall. You may not trust that organization that you've only chatted with a couple times. In fact, you shouldn't. You need to think about these security practices earlier, because fundamentally, from a technical standpoint, probably shouldn't trust your coworkers, because malicious, incompetence, frustrated, like all those things look a lot alike. So think about how can we secure this earlier in the process and solve more problems more upfront. And next up, we need to think about how are we monitoring for anomalies and bad behavior. And it's not just, in the previous session, Alan was talking about performance issues. That's one aspect of it, absolutely. But we also need to think about traffic, usage patterns. We need to think about what does maliciousness look like? In some cases, it could just be hitting the rate limits a lot. But we need to actually think about those things, decide what malicious is, and also just monitor things in general, because even if we don't think it's malicious now, some attacker may come up with a new approach tomorrow. So that's it. That's what I want to share. Once again, I'm Keith Casey. Hopefully you've seen how failure looks like success, because as we started with that API, so successful at those earliest stages, that success bred more success, that growth actually led to our eventual failure. And it led to radical risks and problems that didn't just fall on us as development teams, it also fell on our security team and caused a lot of sleepless nights for everyone involved. So that, I'm going to hand it back off to Jamie. Thank you, everyone.
Hey, Keith. Okay, so great way to wrap up this whole conference. I really appreciate you presenting and giving that entire speech.
Absolutely. Happy to be here.
Yeah, so you actually got a question. I think you already went through it, but I just want to highlight it real quick. So, someone just asked, can a hashed password be hacked? I think you went into that. But...
Yes, a hashed password can be hacked. One of the things that I've always, there are different hashing algorithms. Some of them are significantly better than others. ROT13 is not a valid hashing algorithm. MD5 has been pretty well breached for years now. SHA-1 has been breached. I forget what the current, like bcrypt is pretty good. There's a few others. One of the problems that I've seen kind of fundamental before this is that I've been kind of disappointed on how many people confuse encoding with hashing with encrypting. Encoding is just changing how it's represented to be able to share it across systems. Hashing is a one-way process where you can't get anything back out. Encrypting is two-way. You can encrypt it and then get it back out to the raw text. And it's scary how often people mix up those three.
Okay, appreciate you answering that. So real quick,
Absolutely.
before I move on to the next question that just got popped in chat, I wanted to highlight that for anyone that's interested, I provided links to Keith's book. So we got the link for his book. We have the link for his newsletter. And we also have the link for the OAuth guide. So if you're interested in any of those three, I'd recommend looking into the YouTube chat and go ahead and follow those links. Now, to move on to the next question, you got one from Daniel K here. What is OpenID Connect simply?
Yes, so OpenID Connect is it's a protocol built on top of OAuth. It's not an alternative to OAuth. It's built on top of it, specifically for single sign-on. So it has no relations to OpenID itself, which was rolled out, I don't know, 10, 15 years ago. It's a replacement for SAML. And if you've ever done social authentication, where you say log in with Facebook or with Twitter or Google, and then you log into a downstream website, you've used OpenID Connect. So it's a quick and simple way of being able to do a single sign-on between sites and share a little bit of profile information.
All right. Okay, so you got some other questions actually lined up. So I actually like this one. Isn't OAuth complicated? Can I just use API keys?
Yes, OAuth is horribly complicated. There's no way around that. API keys are sufficient for a lot of purposes. If you have a very simple, if your API only has like 2 security levels, if it's either you have access or you don't have access, API keys are pretty good at that. If you have control over the clients that are using it, API keys are probably sufficient. In scenarios where you have more fine-grained access, where you say, well, this particular API consumer only has access to these 3 things, not these other things within our API, we need to start thinking about scopes, which is an inherent part of OAuth. And scope is basically permissions on here's what you do and don't have access to. In addition, when you start thinking about rotating API keys, API key itself, like there's not a good pattern for that. Whereas OAuth actually has that built in, where it has the idea of a refresh token. And so you get, when you go through an OAuth flow, you usually get an access token, a refresh token. An access token gives you access right now. A refresh token is something you exchange later on to get a new access token. So it effectively revalidates your credentials, your access, whatever, and lets you get a new refresh and access token. So it's got that rotation built into the process itself. It's a mouthful, I know.
Oh, you're good. By the way, God, speaking of just like security in general, I was listening to the middle of your talk. I'm still kind of blown away by the thought of having the last 4 digits of a social security as a password. Like that kind of made me like kind of stop and think for a second, like, okay, probably don't do that. So
yeah, actually that problem that situation was worse because at that company, it was before the concept of a federated or shared identity. So that employee ID and the last 4 digits of your social security number were replicated in every application. So test data, like the test data I had on my work laptop had all that information. It was great.
Oh, that
still hurts.
Yeah, that's definitely good enough for a Black Mirror episode as you described. So
yeah, absolutely.
Nice. So another question you got. Let me see if we go through the list here. So I feel like you did kind of go on this a little bit, but I feel like this is a really important question to really kind of highlight here. If my API doesn't touch any sensitive info, does it simplify my security?
Yeah, so it can. It can. Even if you never touch anything sensitive at all. So one of my favorite APIs is the Marvel Comics API, where you can look up stats on Spider-Man. Spider-Man, if spoiler for everyone involved, Spider-Man's real name is Peter Parker. So if you didn't know that, okay. But one of the things that they actually do use is they use API keys, and they actually have a very simple security model there, specifically because they still need to be able to track API consumption. They need to know who's doing what on their API. So you still need some authentication. Do you need authorization? Probably not, because it's a very simple model. But even then, you could always have the scenario of if somebody could breach your API and use you as a foundation to attack somebody else, having some patterns, having some mechanisms in place ends up being pretty important.
All right. So I've got one last question before we go ahead and kind of wrap up the conference itself. It's
all right.
How does GraphQL change my API security versus like REST?
Yeah, I get this one regularly. So fundamentally, it doesn't. When you think about the authentication process, because fundamentally you still will need users, you still need consumers of your API to be able to authenticate into your API to say, here's what I have access to, here's what I don't. Where things get a little more interesting is once you get into the guts of the API, you start getting into the data structures, you probably need fine-grained access control to be able to say, this user has access to these things, but not those things. Things like, if it was a sales database, for example, maybe you don't want the dollar figures shared with everybody. So you need to start thinking of like, this person has deal level data versus this person just has contact level data. So it doesn't change the security model at the outset. Inside in the authorization level, it absolutely does. You need to get much more specific.
All right. So Keith, yeah, thank you so much for answering all of those questions. I think you did a great job at answering all of them. And this was a great way to wrap up the Serverless and API conference. So before we go ahead and end it, do you have any last things you want to say before you head off?
Well, thank you for Jamie and team for putting this together. Sincerely appreciate it. It's been fun. I really want to just encourage people that dynamic that developers have with our security team, it needs to change. And the way it changes is by having those security conversations earlier and being a little bit more thoughtful in the process. We're all on the same team. Let's act like it.
Yeah, that's a great way to end this. That's a really good point. Well, otherwise, Keith, I hope you have a great rest of the day.
Thank you. You too.
Okay, so that concludes this conference. I'm going to go ahead and go over a few things before to just kind of wrap everything up. Okay, so a few things I want to highlight. Number one, right now at NIMBELLA, we are hosting a competition called FaaS Wars. Rodric kind of talked about it a little bit in his presentation as he was wrapping up, but essentially what this is that it's a competition where you can win cash to create functionality where you control a fighter ship that will attack another fighter ship. We have another round coming up pretty soon where we'll be live streaming potentially your code that you submit and seeing whose code works the best and who will win the competition and potentially win some cash. Next, if you subscribe to our YouTube channel, I would recommend it because tomorrow we are going to be giving a live presentation for a session called Serverless Considerations for an Enterprise. So basically what this talk is going to be discussing companies that are enterprise level or maybe close to it that are already sold on the idea of serverless technology, but are maybe kind of concerned about some of the gaps they're experiencing with dealing with serverless technology and discussing different ways to kind of handle those gaps. So if you're interested, definitely subscribe to our YouTube channel and stay and check that out tomorrow. Now, as I mentioned before, for participating in this conference, we are giving out a certificate. If you're interested in actually getting your certificate, all you need to do is follow this link for nimbella.com/Slack. And what that link is going to do is that's going to give you a special link that will let you join our community Slack channel. Now, from there, you will be able to find a channel called eCertificate. All you got to do is go in there and say, hey, I participated in this event. Can I please get my certificate? Now, I know we got a lot of people from around the world who might have had to leave because, it's maybe 2 a.m. wherever you're at. If that's the case, we got like a nice 48-hour kind of opening for people to kind of jump in within the next 48 hours to get their certificate. So don't feel like you've got to get it right away, but I'd recommend trying to jump on as soon as possible. Now, from the last thing I want to mention, this conference is hosted by NIMBELLA. We are a serverless cloud platform. We kind of went over our platform early on with Rodric's presentation. If you're interested in getting started in serverless technology, especially after you join our community Slack channel, we're available to not only answer questions in our community Slack channel, but we also provide the ability to make an account on NIMBELLA.com for free. There is no credit card necessary. You can sign in with either your email or signing in through your GitHub account. And if you have any kind of questions or are interested in building just a basic app or potentially taking your a startup and moving it to the cloud, definitely get in contact with us and we'll be happy to help you get started on either your journey in the cloud or taking your experience in the cloud much simpler. Well, other than that, that concludes API and Serverless Conference. I want to thank every single person for coming on board, watching either from beginning to end and asking questions. Hope everyone has a great rest of the day.